I'm talking about arithmetic skills. That means doing all the basic arithmetic operations like addition, subtraction, multiplication, and division. Now, I think that some of the students do have problems, am I right, in doing at the lower grade, in doing the addition or subtraction, or even later when they go to the higher grade, they have problem with multiplication and division. Simple things there. So if you face that kind of thing here, what can you do to help the students there? Now, let's look at it. When we talk about arithmetic, we first start talking about counting. Kids, when they are young, they learn how to count first. If you go to kindergarten, basically there are two types of counting they do in the kindergarten. The first type of counting, we call it the rote counting. What does that mean, rote counting? R-O-T-E, means you just say it out, 1, 2, 3, 4, 5. It's like when they try to remember the alphabet, A, B, C, D, E. At that stage, the number 1, 2, 3 has no meaning. It's just like A, B, C, D, that's all. We have not associated a quantity or a value to those numbers yet. When they first learn numerals, we call it the rote counting. Right? You have to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's it. Okay, let's say. Now, later on, they begin to associate those so-called numerals with quantity. 1 means what? They begin to associate that. Okay? 2 means I see 2 apples, 2 oranges, so on and so forth. That kind of a counting is called rational counting. We do all this in the kindergarten usually. These are 2 types of counting they will first learn. Okay? Start with rote counting. Then, once they are okay with the rote counting, they can say that very well, 1 to 10 or 1 to 20. Then they will start doing what we call the rational counting. This is where they start associating those numbers or numerals with the actual quantity. And usually students will have a bit of the harder time with this one in the kindergarten. I've tried it before. If I give them, I say, what's the number here? Some may think, say, you have to start counting 1, 2, 3, 4, 5, 6. They will count your fingers. To say, this is the 6. So not so immediate for some of the slow learners. Okay? So rational counting is the first time they associate numbers with quantity as such. Now, of course, when they come to the grade 1, by then, counting should be very easy already. There's no issue there. But they still count, though, by the way. Grade 1 still count. Right? Anyone teaching grade 1 here? You do, okay? They still count, right? They still count the fingers. Hey, actually, fingers are a very good calculator, by the way. Okay? Don't forget that. It's a good, this 10 fingers, I will tell you, this 10 fingers is very useful for the kids. Okay? Because they don't have a calculator in their hand, okay? Like the bigger kids, so they only have the fingers as calculator. All right? So, they will start doing it. And that's where they begin to learn arithmetic. I'm sure they all learn, first of all, what? Addition and subtraction. That's the most basic thing that they've been doing, right? Yeah. So later on, we will go, as I said, from counting, we go to arithmetic operations. Now, and that's where students somewhere have difficulty with all those operations as such. Because now, no more just plain counting. They learn how to add, how to subtract. So that's the whole issue here. Now, we are talking about 1 digit is not so hard. Come on in. Yeah. You want to sit here? Come, sit here. Yeah. Okay. Now, adding 1 digit and 1 digit perhaps is not difficult to teach. 1 plus 2, they can do that. Or maybe 2 plus 5, they can still very well. But I'm talking about 2 digit and 1 digit number. That is a bit harder because now they begin to 2 digit number. So let's say they have something like this. 18 plus 4 or 23 plus 6. So how are you going to count this? How do you add? I think the best way to do is to use your brain. Okay? So that is what they will be doing now. What they do is that They use the brain and the fingers all together. Bigger number, they put in the brain. 18, I put there. Bigger number, right? 4, I don't have, okay? So what they do is that they count on. 18, 19, 4, right? 19, 20, 21, 22. Okay, 22. So they will start doing it that way. It's okay, nothing wrong. Same for when they are doing 23, okay? Keep the number there, they count, stick up 6 fingers there, and see where it lands. It's still counting though, by the way. Don't forget, these are very young children, they're still doing by the counting method, all right? Okay, now how about subtraction? Now, subtraction, what they do is that what? They start to count what? Backward. Again, same thing, 19, right? Okay, minus 4 now, okay, minus 4, okay? 19, they count backward, 18, 17, 16, 15. That's how they do it. And it's okay. They're still young, by the way. All right, so you have to bear with it. Now, one thing about being a teacher is not so much whether we can do this. Of course, you all can do all this. Very simple. These are very simple stuff. But the problem is the kids. They see it for the very first time. You have seen it for many, long ago, but they see it for the very first time. So try to understand them, see the way they see things, not the way we see it. All right? Well, the way we see it is no issue. But the way they see it can be a problem. That's why you have to come up with all these different types of strategies to help them to learn how to add, how to subtract. So I say, use the brain and the finger. I say, together, they can do it very well, okay? Now, don't put a small number in the brain and have the big numbers on the finger there. That means it's a long time to do the counting. Am I right? So they put a bigger number in the head first, then the finger just for the smaller number. So this is how they do the addition for a 2-digit and a 1-digit number. Now finally, they still have to learn the standard algorithm using the place value finally, no matter what. I'm sure they will do this one, right? Now, without regrouping is easier. You just add it column by column. Am I right? If you were to give them something like 23 plus, let's say, 12, it's easy. There's no regrouping. They can just, line up nicely, those numbers there, and they just add, just like that. Am I right? They will just add like that, and that's it. Very simple if you do the addition. Now, but however, this is not so straightforward because this 6 plus 7, you got 13. Then you have to carry a 1 over. And then 4 plus 9 is what? 13. And then it's more than that, you get plus 1, so 13 becomes 14, and then you carry 1 over. So this carry over thing, they get confused. So what can we do to help them now? This is standard algorithm. I give an alternative way of helping them. They add the 1 first. They know how to add. 6 plus 7 is what? 13. 13, write it down there. Don't hide. Put it there very clearly. Then they start adding what? The 9 and the 4. Right? I add these two already, so I must add now. By the way, this 9 and the 4 is not 4 and 9. It's 40 and 90. They must remember that. It's not just, by the way, by up to here, they have already learned place value. Which grade they learn place value? Grade 1 or grade 2? Grade 1? Grade 2. Grade 1 has no place value. Not yet, okay. So grade 2, they learn place value. So they have to know that this 4 and 9 is not just 4 and 9, it's 40 and 90. So when they start adding it, then they know that it's easy because they know that 4 and 9 is what? 13. But so they put 13, but don't forget, it's in the 10th place, so there must be a 0 there. Am I right? So actually it's 130. They add it up. And that's it. Now there's a now of doing it, which I think is clearer. That means I don't worry about have to carry over. I will just add it at the 1s, write down, at the 10th, then I don't. That's it. A lot faster and easier. So this is, and now when they add the 2-digit with 2-digit number as such. Okay, so that's what you can do to help them. Subtraction. I think use of subtraction is harder than addition. Am I right to say that? No matter what. Now, again, same thing. Subtraction without having to regrouping, a lot easier. They do it column by column and that's it. But you need regrouping something like this. I see my 2 is smaller than 7. How to subtract? I don't know. So, you must, regroup. One of the 10s over here become a 12 minus 7, you get a 5. And then here, it'll be 1 less, already no more 6, it's a 5. So it's a 5 minus 2, so it becomes a 3. So this is a standard algorithm. Again, the kids may have difficulty with this kind of standard algorithm. What can they do? I'll give another way of looking at it. They break it down into what? What do you call this? This part here. There's a name for it. They learned it in grade 1. Forget about this term. Number bond. Yes, number bond. That's right. They use number bond. That's when number bond comes in very handy. All right? They will know how to, if I have a number, let's say 18. I can break it into 10s and 1s. I can say what? This is a 10. This is a what? This is a 8. I can do it that way. Or I can break it in different combination. That's I want. Not only be 10 and 8, it can be 9. It can be 9 here, and it can be 9 and 9 here, for example. Or whatever the combination is. So that's how they would do it, using the number bond as such. So therefore, they are going to do it by number bond. So in that case, they will see that I got 62. I can break it down into like 50 and 12. Because I see there's a 7 here, so I must have at least, more than 7 in order I can do the subtraction. So the only thing that they can do is that what? If I've got 2 here, I would need a 10. So they put a 10 here. So bring out a 12. So 10 plus 2 is 12. They know how to add. So put a 12 here. Then since I have taken a 10 over, this will be what? 60 is a 1 10 less, become a 50. So they start doing it. And after that, they will do it. Of course, they will get a 5 here. And then they will get a 30. They know how to add, as I said before. They learn addition already. So they say 30 plus 5 is 35. That's one way of using the number bond to do it. Anything else? Any question you want to ask me? You think the kids can do it? Is it easier to use a number bond? Up to them. If they can do it that way, but you cannot, they can use the number bond to do it. I'm not saying that they must use this way. I'm talking those who have difficulty with this standard algorithm. Don't forget. If they can do it, of course, you don't need to resort to this method. That's the only thing which I'm going to share with you is that it don't tell on the students. Okay? Yeah. Actually, even in the alternate method, you can still bring them back to the standard algorithm. Simple addition. There's no harm done to bring them back. So that the alternate method basically is to help them to understand what is going on. You see, if you look at just now, you see, when you do it this way, they can understand borrowing means what? That means you are actually increasing this one here to make it bigger to be able to take away 7. That's all they say. Because this, if you do it this mechanically, they can do it, but without understanding. But the number one actually makes it very meaningful. Why I need to so-called borrow this word here? What do you mean borrow? Borrow means what? That means you are breaking the number down into number bond as such. And number bond is something they are familiar with from grade 1 onwards. So my whole idea is this. Even the kids can do it mechanically, but they may not understand what is going on in the whole process. I think today we're talking about learning with understanding. Not just know how to do, I understand why I'm doing it. You ask a kid, hey, why you do it this way? That's what you taught me. That's not a good answer. I don't like to hear that. I say, because I know, blah, 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 I can tell you all these things. I can bring it into smaller number to do the subtraction. I can do something else. So that means they show understanding. So being able to do this is good. But they can do this without understanding. It's just very mechanical, it's a mechanical process. I go through it, don't know why I must borrow, and so on and so forth. But this one put the meaning inside there. So in teaching, sometimes you go a bit more. Being able to do it is one thing. Being able to understand what is going on in the process is something you have to think about, and then this is a good way to have to understand the whole process. Same for addition, just now I mentioned. Fair enough? Okay. By the way, just interrupt me if any question. All right, so fair enough. Now, multiplication. I think this is a slightly harder one. I think when we learn multiplication, anything bigger than 6, 7, 8, 9 is a bit hard. Am I right? They first learn what? 2 times, 5 times, 10 times. You skip the 3 times, you will skip the 4 times. But eventually, 2 to 5 is not too bad. They can still learn it. But 6, 7, 8, 9, this is a harder one. Okay? Now, actually, you see I have my 10 fingers. I'm talking about 10 fingers. Hopefully all the kids have 10 fingers. Not 11 or 9. Okay, please. Those of 11 and 9, they may be a bit confusing. Okay, I assume that most of them have the 10 fingers. Actually, this is a good calculator that they can do it. Okay, now I'll show you how to do it. You see that I put the numbers on all the fingers there. Okay, your thumb, is a 6, and then your index finger is a 7, then 8, 9, and the pinky is a 10. So that's what we've been doing. Okay. Now, so same thing. Okay, you had the two hands here. So you label the same thing. So this is a 6, this is a 7. Okay, so that this is a what? 8 and 9 and 10. Now that's how they will multiply. If I were to give them something like, let's say you want to do 6 times what do you want? 7. Where's my 6? Now, it doesn't matter whether you take the 6, this is 6, right? 6, 7, 8, 9, 10. This is a 6, or 6, same thing. What they do is they take a 6, this is a 7, right? You touch. So I'm doing it. You touch. Now, once you touch, you look at my finger here. The 2 touching finger and this thumb is below this touching finger. Am I right? Now, each one of these finger here, you can is 10. 10 and 10. This one also 10. So you got 1 10, 2 10, 3 10 is what? 30. You see that? These 3 fingers, the touching and the one below, this thumb, make up 30. Behind, you have what? You have 3 fingers on one side, 4 fingers on one side, right? Now, assuming they have learned 4 times. 3 times 4 is what? 12. 12 plus 30. That's the answer. You got it? Okay, well, see here? This is a 6. This is 7 right now. I can touch it this way, okay? Doesn't matter which way you can touch it this way or that, doesn't matter. I can touch it this way. Okay, 6 and 7. 6 times 7, I touch it. Now, once I touch it, I got these 2 touching finger and 1 below. So these 3 make up 10 each for each finger, so 30. I have a 4 here, I got a 3 here. 3 times 4 is 12. 12 plus 30 is 42. Am I right? So 42. Got it? Now you can do it on the, come on. You want to do 6 times, if you want to do 7 times 8 to see what happens, or 6 times 8, up to you. Try and see with your finger now. You practice it. You can let the kids to practice also now. You got it? Or 6 times 9 if you want to. Any problem? 6 times 9. Let's say 6 times 9. How to do 6 times 9? 6 times 9, let's say. How do you do it? Okay, so you count, is it correct? 6 times 9. 9 this finger, right? Which finger? This last finger. Not pinky, this one. Huh? Am I right? I got what? 40, correct? 40. I got a 4, here's a 1. 1 times 4 is what? Huh? It's 4, right? I got how many fingers here altogether? The 10 one. 1, 2, 3, 4, 5. 5 fingers, am I right? It's a 50. Hello? 50 plus 4 is 54. See that? The kids play with, they will play with. Okay, you can give it any number that you want. You can say, 7 times 8, 8 times anything you want. So it's a good way to do the simple calculation if they have forgotten how to multiply. Of course, I'm not saying that they should not memorize the multiplication table. They can, you know. So, I mean, that is basically the whole idea. Okay. Hi. Come on in. It's okay. Don't worry. Yeah, take a seat. Yeah. Oh, okay. All right, so this finger is an easy way to help them to remember that. But of course, once they get used to it, you still can help them to learn using the multiplication table. How to teach them, by the way? How to teach the kids? Okay, at what grade do they learn? 6 times, 7 times? Grade what? Grade 2? Grade 3? Grade 4? Come on. What grade do they start learning? Grade 3? This is about the finger. You come late, right? You don't know how to do the fingers? Okay, I'll show you. Quite simple. 6, 7, 8, 9, 10. Same for here. Okay? Let's say I talk about 6 times 8. This is 6, right? Where's my 8? 6, 7, 8. So 8, right? I touch this one. 6 and 8. I touch it. Now you see when I touch it, the 2 touching finger, how many 2 fingers below 2 touching? 2 more, right? So each touching finger together, the 2 below, each finger is 10 points. So you have what? 1, 2, 3, 4. 40, correct or not? 40 now. On the top, you get what? 4 fingers here, 2 fingers here, right? 4 times 2 is what? 8. If you follow me? For 8. You got 40 already here. So 40 plus 8 is what? 48. Wait, now see. This touch finger, okay? 10 points, 10, 10, 10, 10, 10. 40. Simple, okay? Left behind the top, you can see that my 4 fingers here and 2 fingers here. 2 times 4 is 8. 8 plus 40, 48. So, 6 times what? 8 is what? 48. So that's how they would do it. The finger. Then you can play with it. It can be anywhere from 6 times to 10 times. But 10 times is easy. They don't have to memorize it. It's just that, you know, the finger can take it of the 10 times. So that's how you would do it there, okay, with the fingers. All right, but anyway, as I said before, you know, it's still good to go back to that they will be able to remember it. But I'm just talking about this just in case, maybe in doing something, maybe the test that they forgot, what is 7 times 8? They forgot about it, then the finger can be a good calculator. By the way, you can stop them from using the calculator, the finger though. There's no cheating. They'll show you how, it's okay. This is my calculator here, you see? So they can do it. They're born with that calculator. All right. Now, again, now see, we are talking about multiplication. Just now we're talking about single digit multiplication. All right? Single digit, you know, we have single digit multiplication. But how about 2 digit and 1 digit? And again, without regrouping, it's a lot easier. Am I right? Without regroup, it's quite easy. If I have notice a 151, it's quite easy. 8 times what? 1 is 8. I put 8 here. Then 8 times 5 is 40. I put a 40. Fair enough? Very easy. Without regrouping. But this one requires regrouping. You say 3 times 8 is what? 24. Now, okay, up to this grade, by right, they should know all the way to 9 times. I assume that already. At least 10 times, whatever that is. So they know that 8 times 3 is 24. So it's okay. I'm going to carry over the 2. So you carry over now, or 2. Then you have 8 times 5 is 40. 40 plus the 2 is 42. That's how you do it. I mean, that's how you teach it. We all learned this one when we were young. Am I right? That's how we have learned. But, well, kids having difficulty with this one, what can you do? Again, you bring in the number bond. A lot easier. You see, breaking number bond, basically, you just make it easier for them to see what is going on there. All right? They can bring in the 10th place and the 1st place. They know the place value, by the way. They know this 5 is not a 5, it's a 50. It's a 50, because when they say it's a what? 53. So 53, 50 is a two-digit number. So they say this is 50, it's 50, right? 53, that's how they say 53. So I bring that into this manner. Then I will start multiplying it. Then of course, I know how to multiply 3 and 8, so I can be 24, okay? Then I will see, okay, 8 times this one is 40. Then they start to add up these two together. That's how they will get it. They add together. Because it's every format to addition. It's a lot easier for them to do. Because at this grade, they should know how to do addition quite comfortably already, in a way. Because now they're just learning how to do the multiplication, okay? Now, another way, that is how they can do it. This is not the number one. I can multiply 8 and 3 first, 24. I will multiply 8 and 5 is 40. But don't forget, the 40 is not 40, it's 40 tens. How many tens are there? 40 tens, like 40 apples, 40 oranges. Look at place value as if it is like, orange and apples and that kind of a thing then. I remember, I actually have helped the preschool students, or the kids rather, the kids, learn place value, except without using the word like ones, tens, and hundreds. I never use those. So what I do with them, and in fact, I find that I create into a game, by the way. These preschoolers, they love games and activities that they would like it very, very much. So what I have done is, instead of calling the ones, I give all the very colorful pebbles, and they like it. And all the ones, we call it a white color. And all the tens, I get a blue color. And all the hundreds, red color. 3 colors. Oh, easy. I got the white, I got the blue, I got the red. Very well. Now, we come to trading. 10 white is the same as 1 blue. 10 blue is the same as 1 red. It's a very much I use the money because they know that 1 ringgit is equal to 10 ringgit. They know that. Okay? 10 ringgit is equal to 100 ringgit. So they can understand, when they see the money. So now instead I will use all this trading, right? So because of that, they learn place value, but without knowing these are the place value. They think that it's a trading. And from there on, mind you, they can do all the counting using this color code just to do it. They play with it, and they are quite happy because it's a game. I bring it into a game, and not something you're writing on the board here. So I wanted to do a trading, So they will run around here and there. I trade with you, how many. So these are the whole idea about learning the place value without knowing they are place value. But it's a foundation for them when they go to primary grade. I know the name now. You said that this is a place value. I know what it means now. I see that last time using very colorful pebbles. You see that? So this is another way of helping them, the younger kids, learn a mathematical concept without the labels. Ones, tens, hundreds are just the labels at the end of the day. Even in the language, you call this is a desk, this is a chair. These are the objects, right? But the kids, when they see a table, they know this is called a table or a desk, they will know the term. When they are saying, they call around, look at this one, they know this final thing got 4 legs. They will see this one, they know this is called a chair, but they know I can climb and sit on it. And they see, there are 4 legs there. But without knowing this is called a chair. Only when they go to the school, the teacher, this object is called a chair. Say, now I know this is called a chair. Because I was sit on it when I was young. Now you see, all the terms that we use, whether in mathematics or in the language, whatever, it's only a label to the objects they are already familiar with. That's the key idea. So in teaching many a times, we hide all those jargons, we hide all those technical terminology. You know what? In the play school, in the kindergarten, they learn this is a rectangle. Rectangle is not difficult because it's everywhere. But they wouldn't know how to call this. They call, this is a corner. Good, that's what they know, corner. This table is a rectangle, it got 4 corners. I will never use the word like vertex. They say, this rectangle has 4 vertices. What are you talking about? To the young one. So you must use terms that they understand, they are familiar with. You see? Vertex is a technical term. Another thing, eventually when they go to, eventually when they even go to the primary school, to be quite honest, they see a quadrilateral. You know the quadrilateral is a four-sided figure. But we now use the word quadrilateral for the younger kids, which is a four-sided figure. The only thing that they have learned about the name of a shape is only up to the triangle. They know triangle. But four-sided, they may not know. For four-sided, they only know certain types of four-sided figure. They learn a square. They learn a rectangle. These are two basic ones they will have to learn. They may eventually learn what? Parallelogram. Eventually they'll learn the trapezium, and that's about all. But what is a four-sided is not. A parallelogram is not, it's not anything else. It's a quadrilateral. But this term had never been introduced in the primary school. We just say that this is a four-sided figure, that's all. Because I don't know, four-sided. So therefore, all this term like quadrilateral, whatever that is, of course in secondary they will learn about pentagon and all the higher level there. It's just referring as a name given to an object with many sides. And that's all. That's what it is. You follow me? So that's about teaching the kids without using you see, the whole idea is that help them understand the concept first. Terminology is only a label associated with a concept they've already learned. Follow me? This is what I'm talking about. So these are the same thing here. You can also do it this way. And of course, once they do it, it's quite simple. They can see that, the 5 is not 5, it's a 50. So 50 times 8 is what? 400. You get it this way. You see that? This way is easy for them to do it. It's easier. Without having to do it this way anymore. Am I right? I don't have to do it anymore because they don't know how to add together column by. But they write, okay, important thing. They must write column by column. That's important. Place value is important that all the columns must be aligned. The key thing. Once they do that, it's easy to do it. Okay? So if they find that this is difficult to understand, do it this way or this way. Up to you, depending on the cohort of the students. That's even lucky worse. What grade do they learn? Grade 4? 5. What grade do you teach now so far? At low grade? You only 5 and 6. Do they do this? Which grade? Grade 4. Their difficulty? I'm sure that you know this procedure, right? Okay, I know. We are all familiar with this procedure. We all learned this when we were kids. Of course, we know, doesn't mean that they know. They also don't know what to do. It doesn't matter. What you know doesn't help the kids. They can do the same. So what can you do? Okay. Now, this is one of the ways I will show you how you can do it. I'll start doing it this way. Only 3 times 9. They know that, how to do it. 27. I write 27. Straight around 27. Then I know 5 times 3. Okay, how do I know? Wait a minute, I get this one again. Then I will get this 9 times 6. Sorry, 9 times 6 is what? I will know how to do it, right? 9 times 6 is 54. But by the way, the 6 again is not a 6, it's what? 60. So therefore it must be what? 54 tenths. That means 540. So I put a 0 there. You see that? That's important. This 6 is not a 6, it's a 60. That's important, okay? The place value there. So 9 times 6 is what? 54 tenths. 54 tenths. Okay? No. Then I will start doing it. So 5 it's not 5, it's 50, right? 50 times 3 is 150. I put it down. Then last but not least, 5 times 6 is what? 30. It's not 30, it's 30 what? 100. So I put down 3,000 here. So I'll add. So all this is about adding all together. A bit longer, yes, but they can still do it. Slowly. If they don't know, if they have difficulty with this one here, this will help them. Now, this one, in a way, even look a bit tedious. It's good in the sense that you reinforce what? Place value. Oh, by the way, place value is one of the important concepts in mathematics for the primary kids. I tell you that. They learn that, they need that all the way from the grade 2 to grade 6 without fail. In grade 6, they just need to remember the place value. That's important. Okay? They must have good foundation in place value. So I'm using place value here, to do this as an alternative method for the standard algorithm. This is one way of doing it, a bit longer, so you can write answer as such. Oh, by the way, if the kids do the test, do it in this way and give to you, don't mark it wrong. It's correct. Don't force it, you must do it in this way. This is valid. So please do, be more merciful to the kids. Don't insist, it must be this way, can it be another way? No, come on. One thing about mathematics, you can solve a problem in different ways. I'll give you another way. I used what we call a box method. Now, you see this is a what? This is a 2 by 2 box set, right? It's not square. I mean, you can draw a square if you want to, but they make it looks like a rectangle. There are 4 small little rectangles to make a big rectangle. It's okay. And I start breaking it down. Now, you see what I'm doing? I break that number down into what? Tens and ones. And the right is where I say, this is a 10, this is a 1. So same, 60 and 3, 50 and 9. And they can do this very well. They can look at the numbers. Oh, I know this is a 60 and a 3, 50 and a 9. They put it down. Now, if they put this pair on the top, it doesn't matter. I don't care whether the 50 and the 9 is down here or it's up there, 60 is down. It's the same thing. Okay? It makes no difference. Now, that is where they start multiplying. One by one. So start doing it. They know that. They know that. Right? At the end, same as what you see earlier on. Get together. So they can use the box. You see, the whole thing about all this is that we have the kids to do one thing at a time. That means when I start multiplying 50 and 60, I don't need to worry about all the other numbers. I do one thing at a time. Because this way I force them to do too many things so that they cannot take it. You see, there are too many things they have to do all at one time. Oh, when I do this, I must be able to carry over, blah, 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 so and so forth. But this one is a box method. They only remember, okay, if I do that 9 times 3 is 27. I don't worry about all the others. I just take care of only 2 numbers to work with. Follow me? So, you think this is easier for the kids? The box one, up to you. You want a box one, this one doesn't matter. Actually, it's the same thing. Look, it's the same thing. Okay? I put it the other way around. That's all. So these are the ways and means kids to learn how to multiply a 2-digit and a 2-digit numbers. But of course, if they can do it this way, it's fine. But again, this has got one advantage. It actually reinforces the place value again. Am I right? This one, still there, but it's a bit not so obvious. They don't see this 2 is a 20. This actually is a 20, But they say it's a 2, they say it's a 1, but this is not a 1, this is a 100. So it became, you see, but this one, you really force out the 100 to show them what that is. So that is the beauty of this method here. Though it may appear a bit longer for the kids to learn, but it really, reinforces the concept of place value. Clear enough? You can try, you can try with the students there and see. Yeah. What grade are you teaching? 1 to 6. Oh, okay. So she cover all the way from the lower to the upper grade all the way. Good. Okay. Now today you see everything already from 1 to 6. How about you? Are you teaching at what grade? What grade are you teaching? 3rd grade. Also, okay. So 1 to 6 also, you got okay? Yeah. Now, when do you do it? Can you do it using the alternate method now? Why don't you try? Come on, you try. I'll give you this number here. You can use the box method. You can use whatever method they use. Okay? You try and see what happens. Just write it down somewhere on your, I said, using the 2 alternate methods, okay? You can just try it. You want to use a box. If you want to use row by row, up to you. You do it. The first one, anybody use the box method to do it? You can use the box method. You can do it by the box method or the number bond. Up to you. You decide. It will be only 2 boxes, right? Right? We need two boxes there. Okay. This one, of course, is the standard one. You got what? 4 boxes here. Fair enough. You got 4 boxes here. How about this one here now? Anyone want to show me how to do the last one? You show me? You want to show me how to do the last one using the box method? Okay. They add it all together, right? Okay, good. Okay. All agreed? Do you do the same way? Hello, yes or no? Yeah. Oh, by the way, the box that you can do it, you can also draw it in a different way. Am I right? You can draw it in this way also. Am I right? I can have my 10. What? Okay. Right. I got my 10 and 3. I got my what? 200 is here, right? So same thing. You either draw it this way or it's the same multiplying out one by one. So this is a box method that you can do it. Okay. It's quite easy. The kids can easily draw it as such then. And instead of doing it in the traditional way, if they find it difficult, give them this way to do it. Now, if they give you a box and get it out, the answer is correct, you should mark it right, to be quite honest. We never enforce it must be done in the standard algorithm. What you want is that they must know exactly what is the process of the calculation. That's what I want to enforce. Again, this method, in a way, helps to reinforce the concept of place value once again. Okay, so much for this one. This is very easy. This is the worst thing. Multiplicity is not bad enough. I think division is the worst. Okay. Now, this one is what? Grade 5, isn't it? 4. Grade 4. Oh, okay. I can't remember. Grade 5 and 6, do they do a 2-digit divisor? Do they have it? Or they don't have it? I can't remember. Do they have 2-digit divisor? Or it's always single digits? You'll be teaching, so at the higher grade there, do you remember whether you have it? I can't remember whether. Do they have a 2-digit divisor for the higher grade? Probably. Huh? 3 and 1, huh? So I suspect that if 3, then 4, 5, 6 must have someone touch on the 2-digit. Maybe. Okay, never mind. Let's start with the simple first. Now, that's what they'll be doing. And I'm sure that all of them are quite familiar with this whole process. You can do it very well. Now, the only thing is that they must understand, I put a red 0 there. Because when I say 6 versus 17, okay, divided by 6, you get a 2 here. But actually, it is not a 2. This 17 is not 17, it's what? It's 170. It's 17, what? 10. 17 tenths, so I'm time of 0. This is in the tens place, you know. Am I right to say that? So I put a 0 there. It's good to put a 0. I always never know how to 0. I know many times we know where actually it's a 0. To know that what you get 6 times 2, 120 is basically 100. Basically it's 120. It's not 12. You know, to be quite honest. So I purposely put a 0 there. Then do a subtraction, and they will do the last one, which is this one here, right? Fair enough. This is a standard algorithm. Now, if the kids have difficulty, here's another way of doing it. I use the place value again. Up to here, they will know how to break it down, the place value. Up to now, they will know numbers that are divisible by what number? Smaller number, fair enough. So for example, I can break that into 120. I know that because 12 can be divided by 6. So I put 120. Okay, now what is this one here? This is only the remainder, am I right? I think I would subtract 120 from 174. I will get 54, obviously. You break it down. Okay, then you start divide now. I know how to divide this small number. I'm not sure how to divide it, but I know how to divide this number. I know how to divide this number. So you break it down, something smaller that I know how to divide. It's key idea. Now, the way they break it down may not be exactly the same as what I'm putting. This is only one example. For number bond, you can break a number down in many different ways. Don't say that this is only the breakdown. I can break it in different ways, by the way. That is important. What they want is that I want to break it in such a way that the number I'm looking at can be divided by 6. That is all it takes. That's all it takes. That's all. It's quite straightforward. Okay, so that is basically what it is. You break it down, okay? I just show you this. Now, once I start dividing 120 by 6, I get 20, obviously, because I know how to do all the simple division here. I simply add up these two together, I'll get 29. That's it takes. But as I said, the number inside there sometimes may be different from what I put down here, because the kid may decide how to break this 174 into a pair of numbers that I'm comfortable with. That is all it takes. You follow me? Okay. So of course, usually I will break it down as simple as possible. So this is a way of doing it then, and you add it together. Now, we talk about 2-digit now. Now, this is the worst one, am I right? This is the worst one. Huh? And this one, you make it even lucky worse. That's remainder also. I thought you give it this is with a remainder. I mean, this is an algorithm. Assuming they will how to do it, and then they will have to do it now. How do you know I must start with a 2? With a try and error. Am I right? They start with a 1. Or they start with a 2 or 3 or whatever. They will start the first one. Then they'll do it. Usually the first is difficult. Second is not so difficult that they can still do it. But remember, I put a 0 all the time. You see that? I want to enforce the place value here. What you do is that it's a 2 times 12, 24. But actually, this is in the 10th place, right? So actually, when you start doing it, it's actually, it's a 24/10. So that's what I've been doing. The subtraction, then they will get a 70. Again, they will start doing the multiplication here. 12 times 5, that's the largest possible product is 60. I still got a 10. Sorry, my 10 is smaller than the 12, so that becomes a remainder. Standard algorithm. This is hard for the kid. Not all the kids. Some kids can do it, yes, but some cannot. Then how? So, I use the place value again. I start breaking it down. I got 310, right? I break it down into something I'm comfortable with. Again, this is only an example. I know how to divide 24 by 12, so I put 240 there, a big number. I will know how to divide 60. I'll put whatever left, after I take away these two from 310, I will get 10, for example. Now, they may do it in this way though. They will start with 120. It's okay. Then of course, this number can be a bit bigger. So they will break down whatever form that it will take. It doesn't really matter. All I want is to find some number I'm comfortable with, which can be divided by 12. And usually when you do that, your mindset is a reward. You think about what? I want to talk about multiplication. What times 12 will give me this number here? Am I right? Because, 12 times 10. Oh, I know 12 times 10 is 120. I put 120 here. They will start doing it this way. Then they'll see. Then they'll put 120, okay? Then what they do? Oh, subtract, still a big number, right? I can see what? So they can put 120, 120. Or they can put 120, or they can put 180 if they want to, because they know 80. So they will decide how to do it. So you 120, 120, 60 and 10, up to them, whatever that is. You follow me? So they use the place value, they would do it. Of course, they will get a 25. Yeah. Same as this one. This is a dividend, which they will get. And they don't say, the 10 is too small, I can do anything. So this will be my remainder. Because two-digit number, division is harder. So therefore, you can see my number bond also getting a bit more complicated. Okay? Yeah. But see, throughout, again, we reinforce the place value. Now, you want to try? These two numbers. The first one is a division. The divisor is a single digit. The second one, the divisor is 11. So you try and see what happens. Use a number bond to do it. You've done it? You want to show me the first one? Come on. The 174 divided by 3. Okay. All agreed? All doing the same way? Oh, okay. All great by thing alike. Okay, good. How about the last one? Anybody? The one in the back want to do for hello? You want to do for me? The last one? Oh, you want to do it for me? How about the lady there? Do it for me. The last one. This one. You need to do okay. Anyone have done 265? Have you done the 265? You didn't do the 265. Have you done the 265? Okay, you show me how to do the 265. Okay. Okay? That's how it is done. Fair enough. Anybody have a question about this one here? You do the same way? You've done it? Okay. Yep. You've done it the back way? You've done it this way? Okay, so that's how you would do it. You break it down. Now, by the way, he started doing it at 220. Okay, fair enough, because he can see that 20 divided by 2 is a lot easier. So fair enough. I would just do it in that manner there. So so that's how he's doing it. Of course, this can be a different number. It can be even a small number. You ask. Remember, it's 1. 20. Okay, we add together, do we have? Is it bigger? Let me see. 220 plus 55 is what? 275 is too big already. Okay, so it's okay, don't worry. Then we make it a bit smaller, right? So we cannot do this, never mind, I make it a bit smaller. So what should I put there? Okay, it starts with 220, it's okay now. 220, okay, after I subtract, what do I get? I got 45. I got 45, okay? 45, but 45, okay, I don't know, but 44 is okay, right? 44, okay, good, I put 44. Once I put 44, then I know this must be a 1. Fair enough. You see, I just simple subtraction, so they will do it. Yeah, okay, good. So I will do it this way. So once I do it this way, then this will become a what? This will be, this okay, this fair enough, okay? But this will be a 4, fair enough? This will be a 4. And so therefore, my answer will be 24, am I right? 24. And this is a 1. Okay, good. Now, I think this is a very good example here. You see, once the kids start doing it this way, come on, mistake, everybody make mistake, including me, I also make mistake, to be quite honest. It's okay, nothing wrong with making mistake. But I want the kid to realize that before they go on to do the division, they make sure that these three numbers, this is a number board, by the way. When added together, it must be exactly the same as this number, no matter what. It can be bigger, it can be smaller. So if a breakdown is not correct, then they do it one more time. Means everything is correct before they can proceed further. That's one of the things there. Okay? It's a good example to look at it. By the way, I just noticed that in my handout here, I got one more example, which for some reason I don't know why it's missing in my slide here, which is it is a 301 divided by 7. 301 divided by 7. Now, okay, good. Okay, never mind. This is not in the, it's in the notes there, but it's not in my purpose. I don't know why it's missed. Never mind, it's okay. Now, I never know do this one. Come on. How do you do this one? Anybody? Now you do it? Okay, now you do it. How to break it down? This one. Agreed? Okay? So the kid must also know how to break it down in this way for this question. Okay, good. So number bond is useful. You have them to simplify the process. Okay, bring it into smaller number, something that they are comfortable with. They can do easy, division as such. But of course, if those find that it's a bit difficult, they can still bring it. You can put a lot more if they want to be quite honest. They can put this is only 2, right? There's only 2 here, but it can be 3, 4, up to them. Some of them can pick a bigger number, they want to do a smaller number, it's okay. Let them do it then. So that's the whole idea about this, They can even break it down, this one, instead of 280, you can put 210. It's okay. And bring it down further, 210, and 210, then bring it down a few more. No, this is a no harm done. Of course, because you can see that I can pick the biggest, it's a 280, but some people can pick the biggest, they get the smaller one. Okay. Okay, it's good. The time is good. Oh yeah, I see it, by the way. I thought it's not there. It's hidden. Sorry. Okay, that pretty well cover all the thing about the basic arithmetic operations. I'll give you some of the alternate methods here to see that for kids who have difficulty learning the standard process or standard method to do it, the alternate will help them to understand. Okay. You can also use the alternate method to strengthen the understanding of the standard algorithm. You follow me? Yeah, because that one is very good with emphasizing the place value. What's going on in the standard algorithm. That's the whole idea. Now we come to problem solving process. Now, this is the main bulk. Arithmetic is very simple, very basic skill. They must master no matter what. If they have problem with the basic arithmetic skills there, then we come to problem solving, they have difficulty. Okay, so by the time when they come to problem solving, we assume that they know all the basic arithmetic operations very well. That's important. So that part had to be done at the lower grade. Make sure you enforce it. Now, by the way, problem solving, I said that is a central focus of math education. That's a key thing. Basic arithmetic operation, yes, it's important, but it's not the central focus. Problem solving is a central focus. And I said that it goes beyond simply finding the right answer. Because it's a process. Right? Problem solving is a process. So that means the process is important. We're going to find the answer. But the focus is not about the right answer. The focus is about the process of finding the answer. That's what that matters. Now, during the process of finding the right answer, of course, they must understand the problem, and they know how to analyze and then apply what? Mathematical concept. That's the whole idea, okay? Oh, yeah. Situations can be something they are familiar with, something they're not familiar with. There's something I don't know, what kind of situation is that? So it can be both familiar or unfamiliar situations, and that's what they'll be doing. What's the whole idea of problem solving? Help to develop critical thinking, logical reasoning, and adaptability. These are the three keywords. The whole idea about problem solving is not just of solving the problem, it's to develop critical thinking, logical reasoning, adaptability. I can adapt to any kind of situation. Something I'm familiar with, something I'm not so familiar with. Oh, by the way, that kind of mindset is not only confined to mathematics. It can be used in other subjects, especially in science. Science also requires critical thinking, also requires logical reasoning and adaptability. Because sometimes in science, the word problem there, you are not familiar with the situation, but you see the problem is facing you now. How to solve that kind of problem. So these are the important skills they learn from mathematics that can be used in learning other subjects. Sometimes I call these are the life skills. Actually, we apply all these skills in our life, whether we know by this term or not, we'll be using it. I'm sure that if you are driving, or you know how to drive, or you don't drive. Have you been to a place where you're not so familiar with the road system, where to go? It's a my goodness, this is a new place. Or you go to town, have been redeveloped or changed. Sometimes government will change the roads here and there, right? You've not been there for a long time. How to go about these places? Something you're not familiar with. No. You have to adapt to that unfamiliar situation. Something you know before, but not totally changed. So these are the kinds of things. You apply that. How should I travel? Do I go this road or that road or whatever that is? So this is the whole idea about adaptability. Okay? Critical thinking. Of course, now it's a very good. Now you got the what? You got the Waze and the GPS there. It's okay. I can look at it. Oh, heavy traffic. I will skip to go another way. Am I right to say that? So these are kind of you must adapt immediately to decide what should I do. In fact, one more thing which is not here is called the decision making. This I know that's important too. It's decision making. This pen. Okay, decision making. Kid must learn how to make decisions. That's important. So these are the life skills, to be quite honest. And they're using mathematics to develop the life skills at the end of the day. Okay? Another thing, problem solving also helps to build perseverance. That's the hardest thing today, in today's world. Because kids want what? instant gratification. I want it now. Thanks or no thanks to all the technology. In the good old days, you're away from your friend, too far away, okay? Let's say you're overseas. What can you do? You call? Expensive. You send what? Letters. Well, I think donkey days to go to you. Okay, say your letter, palm, it take about 1 week. If I'm somewhere in the States, whatever, just send you 1 week, then wait for you. If you write to me immediately, another week comes. So about ding dong, about 2 weeks already. Okay, later on, very good. Got email. Email you, that's a lot faster. But email, because you may not read it immediately, you may stay there and away, and then you wait for another few hours or another day before you reply to my email. At least it's faster than the snail mail. Fair enough. Email is better. Not good enough. WhatsApp, faster. Pop, immediately you get it. Pop, immediately you can get to me. So you see, there's a trouble with today's world. The kids are so spoiled with all the technology. They want instant gratification. I want now at this moment. Because of that, they don't persevere. They look at the problem there, not more than 5 minutes. Teacher, I don't know how to do it. Very fast. Know the thing very hard. I don't know how to do it. You just tell me how to do it. So fair enough. Please. I think kids must learn how to build perseverance. You agree that this is a good character to develop? In life, by the way, many times we're going to persevere. You believe me or not? Not everyone wants to go in their own way. Okay? I want to go to this way, but sorry, there's no road here. I must find a way to get to your place. You're going to persevere with it for the meantime. Okay? So no choice, you're going to wait. So one of the things they try to develop it, because once they develop this is a good character building, to be quite honest. I always emphasize on this one. Use mathematics to help them to build this character here. Okay? Now, once they master problem-solving process, it will prepare them for more advanced academic study in different disciplines, even in the professional success in the future. That's important. So these are the whole idea about problem-solving. It's not just solving with a few questions there in the test or in the exam. No, it's more than that. You actually develop the character to face the future world, put it this way. All right? So that's the rationale of problem solving. Now, I show you this is basically a Singapore mathematics curriculum framework. This Pentagon has been with us in Singapore for many, many years. But through the years, it has been revised, updated. But still the Pentagon. These 4 components never disappeared. And if you look at this big Pentagon here, which part is the largest area? The circle. The circle inside there is what? Mathematical problem solving. So in other words, in math education, problem solving is a central focus. It's the biggest area they have to do it. So therefore, you look at the kids, what they do most of the time? Problem solving in Singapore. I guarantee you. Look at our kids there, do problem solving all the time. Okay, now that's the reason why problem solving, be careful. It doesn't mean that if you give me 100 questions, I meant to solve it one by one. Of course, this is good. That's called problem solving, yes. But do they know what they are doing? Because we try to move away what we call from the rote learning. You know the rote learning? We try to move away from rote learning. Rote learning means I learn by heart. I memorize it. In the good old days, our kids, Singapore, in the good old days, in terms of Singapore, I think same as Malaysia also, maybe. The kids are very smart, you know. You know how smart they are? The kids will teach them about different types of problem solving, right? They memorize all the steps there. That's how I should do it. It's a pattern. When I see a question similar to this kind of thing, I take the whole thing, change the numbers there, and get the answers. Good. So they have a few typical patterns to look at. Maybe 4 or 5, whatever that is. Okay? So they memorize all the 4 or 5. If I see this is a problem, this is a way to do it. You see this one, this is a way to do it. Okay, good. But one day, they see a problem that may not exactly fit all the 4 or 5 patterns they have learned. Maybe they see something, part of it is pattern 1, part is pattern 2. How to combine? I don't combine the patterns all together. You follow me? Because I learned by patterns. I say, pattern 1, 2, 3, 4, 5. When you come with one, half of pattern 1, half of pattern 2. Or maybe a 1 quarter pattern 1, another 1 quarter is pattern 2, another 1 half is pattern 3. Worse still. So how to solve it as such? That's called the rote learning. Even though I can solve 100 problems there by recognizing the patterns there, there's no real understanding. You follow me? So in other words, the whole issue is about making this more effective. And you need all these things together to develop that kind of problem-solving skills. This one, I'm sure you know what I mean. All the concepts about what they're supposed to learn, whether it's numbers, whether it is shapes, data handling, all this are here, all the operations. To talk about arithmetic operations, we talk about ratio, percentage, all these things, all kind of this concept learning is just important there. Now, skill is important. Learn how to add, how to subtract, how to multiply, how to divide, how to do all kinds of manipulation here. All right? But what is important, is missing, is the processes. Now, that is where I try to emphasize it. These two are very standard. In our traditional education, your time and my time, we are very good with concept and skills. Am I right? We do it. But this one, now talk about processes. What's this? We talk about competencies in abstracting and reasoning. Representing, communicating, and applying what? Modeling. All those things there. Now, these are the processes which is a bit lacking, unfortunately. Singapore now will beef up in this whole area. I think in Malaysia it's still lacking in some way. Am I right to say that? Yes, we need this one. Be able to do how to abstract something out from what I want to see, how to reason things out. Okay, how to communicate. Now, that's one of the things. Communication is another key thing in mathematics. Now, in mathematics, we have something called communication. In the past, we never had. The kids will solve problem solving, that's it. Okay, now say, no, explain why you do it this way. What's going on in your process? I give you a scenario. Look at it. Two persons talking to each other. Each have their own view or points of view, for example. There's A and B. Do you agree with A? Tell me why. If you disagree, tell me why. So learn to communicate. That's the whole idea about communication. That means you want the kids to be able to tell you their thought process. Oh, this is what I think because here's my reasons. You see that? Because you cannot read the kids' mind. You know how they would really, you also have to explain to you what goes on in your mind. So that's why you need communication. And when it comes to communication, what's important? Language proficiency. So nowadays, when I talk about mathematics education, I focus on the language proficiency. That's important. Because we want the kids to be able to communicate. They can either explain to you or tell you verbally or in writing. Either way. You put it in writing or you tell me verbally in the class there, what is your thought process? You tell me. So as a teacher today, we try to encourage to speak up. Tell me. So now, one thing about mathematics, unlike language, they can tell you verbally, yes. But one thing about mathematics, they can tell you what? Through pictures. I can draw pictures. And it's good. If I'm a student there, I can't say everything in words. I draw a picture. Teacher, that's what I see. I will draw a picture, show you. I point to you the picture there. That's what I'm doing here and there. So like that. That is also a form of communication in mathematics, by the way. Through diagrams and picture, they use it to communicate because they're not good with so many words. But with pictures, they can say a lesser number of words, but they can explain what's the mindset now. What is important to you as a teacher? Not so much of how good is the language skill. You are not going to pass about the language, whether your grammar is correct or word choice of words correct. No. It's to access what? The understanding. The key word is that you access understanding, not about the language skill. Language is only for you to help you to understand what is in their mind. That is all it takes. Picture is a way that's how they see it. It's good. If you want a picture to explain what's going on, be my guest. Use the picture to explain to me what's in the picture there. That's all it takes. You've gone through the bar model, all of you, before, right? Now, the bar model is a form of condition, right? Once the kids draw the bar model, it tells you something. Let me understand what goes on in those words there. Am I right? I have a picture, I see, oh, now I know the kid, what's in their mind. I can see very clearly. Even though it's nothing verbal, but in pictorial form, it's a form of communication. You see that? So, this is the important thing about this whole process here. This part here, what's the metacognition? Be able to look at the thing and reflect on it. Okay? Be able to monitor your own thought process. Tell me what's inside there, okay? Now, many a time when they solve a problem there, the question is, there could be more than one way to solve a problem. That's important. So sometimes I have encountered students who are very good in problem solving. Before the whole class finished solving the problem there, this smart Alex finished much earlier than the others. I said, teacher, I'm done, happy. I look at it, well, good. So I've asked the question, can you do it in another way? They look at me. You mean, teacher, you mean there's another way? I said, I don't know. But if you don't think, how do you know there's no another way? Right? You think about it. So they start to think, can I do this in another way? This is called the power of metacognition. You want to find what is the most elegant way, or maybe a shorter way to solve the same problem. You see, these are the whole idea about metacognition to force them through. A simple metacognition is that when they finish a word problem solving it, do they spend time looking through one more time, understand what is going on in the mind process? Maybe they make a mistake somewhere along the line. Can they see it? They don't bother. Teacher, this happened to you already. Am I right? Please, because they have no perseverance. They get the thing out of the way as soon as possible. I don't care. Pass to the teacher. Hey, this is not mine, this is yours, by the way. Come on. I think we are trying to cultivate an idea. It's called the what? Ownership. What's ownership? I own up what I learned. What you teach me today is not yours, it's mine already. Because I own it up already. It's mine. It's not yours anymore. The trouble is that today I learned something, that's from you, teacher, it's not mine. At the end of the test, back to the teacher again. I don't need it anymore. That's where the trouble is. So when I go to the next grade, the teacher and the higher grade teacher say, oh, by the way, last year I learned this one. Huh? Have I learned this? I forgot already. Am I right? We're going to take everything back to the teacher. What? So the whole issue is about ownership of knowledge, of content. It's a key thing we try to cultivate. And there are many ways to have them own the knowledge. There are many ways. In fact, through activities is a good way to do it. Okay? If something they put in lots of hard work and effort there, I guarantee you, they will treasure what they have done. I ever do a kindergarten. Because I have a kindergarten program for the younger ones, you know. So one day I stepped into this kindergarten center there, and I look at, they have a cow made of, milk cartons. The little milk cartons, triangular milk cartons there. They shape together, put together. Very nice, I look at, oh, very nice. I said, where did they get it? Oh, these are the rejects from the factory because somehow the label is wrong. So they cannot give it, to the so-called, to the buyer there. So these are the rejects, but it's clean. Okay, there's no way inside this clean. This is a box only. So they take that one, and since they don't want to throw away, we take it and they use it as a material to help the kids to learn how to build. Something is about building shapes. So they build a little cow about the size of this one here. Okay, I said, oh, very nice, huh? And they say, I said, I can sit. Please don't sit. You say, the kids will cry. You're going to crush it later on. You say, don't sit, huh? Oh, don't sit. Okay, don't sit. Step away. Why? Because the kids spend about 1 week just to make a cow, using the milk cartons. And they treasure it very much. Wow, effort, I put effort. I make it, If I crush it, I tell you, what do you think? They'll cry. So please. So one thing about it, if they put some effort, learn something, and they get something out of it, they treasure what they learn. I own it up. Same for mathematics. So, and this is perseverance. If they sweat a bit more, they do something, they say, oh, it's good. Now I can do it. Somehow kids are very strange. They think they cannot do the one they cannot do. Once they can do it, it's a kind of reward to themselves. Oh, I can do it now. That's the whole idea. So, okay. So that's the reason why we need this one here. That one here, attitude, easier said than done. I'm sure that in general, kids hate mathematics. Am I right? Let's be honest with it. I don't like it. It's a necessary evil. I must do it. Why? I'm going to pass the test and exam. It's a compulsory subject. I must do it no matter what, though I don't quite like it. But the trouble is that they don't see math is everywhere. They see math is not confined to the four walls of the classroom. And that's it. Outside the classroom, there's no more mathematics. They forgot about, okay? So that's the reason why in EduSeed, we organize STEM Trail. You know STEM Trail? We take them out of the classroom. And that's where they begin to understand mathematics in the real world context. How math is being used in the real world context. In Singapore, we do that also. But of course, not every day. Maybe once maybe after a few months during the break time, we'll take them out for half a day or whatever that is. And that's where they will do all kinds of activities involving math and science. We call it the STEM Trail. You know what STEM, STEM. What's that? Science, technology, engineering, mathematics. And they apply all those things to learn. And that's where they begin to see the math comes in. And they apply mathematics to solve problems in the real world. Oh, it's good. I can use my math now to do measurement. How tall is the tree? How tall is the tree? Let me climb the tree. Drop down there to say, hey, don't do that. It's too dangerous to climb a tall tree. Am I right? Don't do that. How tall is the coconut tree? So tall. You climb up. By the way, you are not a monkey though. Monkey can climb very fast. I know that too. Okay? You see the monkey pluck coconuts there? I've seen it before. It's quite cute. This little monkey climbed the tree there, He will turn the coconut, turn it down, pop, it will drop down, right? Yeah, they train the monkey to pluck coconut because we cannot climb up there. We are too big a size, too heavy. Monkeys are very fast. They go up there and pluck them up. So, but we can't do that. How to measure the height of a tree? They'll think about that. They will do all kinds of things there. So that is something they will learn in this way. Then they appreciate, oh, I learn math because I can use it outside the classroom. So try to develop an attitude. Hopefully it's a positive attitude. I know it's not easy to change the attitude, the mindsets, but it can be done. I won't say it can be done. Maybe a bit slow. I give activities before, by the way, to some of the grade 4 students long ago. I do the activity-based learning. And they love it because finally the math is all activity-based and they start playing here and there are all kinds of games they will start playing, learning all the mathematics there, So at the end, I asked the feedback, about the students there. I still remember until this day, I never forget, it's a girl. And she told me one thing. I used to hate mathematics, very honest to me. I used to hate mathematics. Now I hate a bit. Oh, good. Some improvement, still hate it, but a bit only now, not so much, a bit lesser. It's even speaking. We have to help them to cultivate that kind of a positive attitude in learning mathematics. I don't expect them to be good in mathematics all the time. They are not going to be a math expert, never mind. But to know math is useful in the everyday life. That's why I learned it. That's all it takes. Okay? So that is the harder part. So as a teacher, this is your job to ensure that the kids, if they want to do problem solving, these are the 5 areas, 5 components, make it all rounded, to help them develop the kind of attitude, the kind of perseverance, be able to handle mathematics in problem solving. I know teachers have a big challenge in handling all this. In teaching, you're not thinking about how good you have the math knowledge. That's not important. What you know about mathematics, nothing to do with the kids. What you know, they may not know, so it wouldn't help them. Your whole idea is to be able to help them understand what they're learning. So that's the reason why we have these 5 components there. But of course, I must say that, the harder part, of course, It's a process of doing it. I mean, I said already, this is a life skill, right? This is a life skill. So actually, in problem solving in math, we also develop skills for life. Okay, I said that already many times, so I don't need to repeat this. So that is the crux of problem solving. How do we define a problem? Is 1 plus 2 a problem? Or 3 times 5 a problem? Not a problem. This is a very procedural, very mechanical. I call this a very basic skill. This is a skill development, okay? A problem is one that what? No ready-made procedure can be followed through. You cannot follow through. There's nothing fixed. It must be in this way. It's not a machine by itself. And you need to explore the different process. What goes on inside, you can explore. Not straightforward. You need to apply what? Strategies. And to solve it, it may be multiple steps. You involve some complex reasoning. You look at all these things here. Does this sound very much like what we face in our everyday life? You think about that, besides mathematics. Do we have all these things that we have to handle? Something that's nothing ready for us to follow through. How to do it? Am I right? Nothing, there's no real procedure to follow through. How to do it? Some of the things that you have to decide. Okay? So, and you know how to do the things there. Even a simple thing that you want to take up a loan from the bank or whatever there. What do you do? Which bank you want to go to? There are so many banks. A, B, C, D, whatever that is. They give you different plans and whatsoever there. You want to take a car loan, you want to take a housing loan, or any loan that you want. And about the repayment or different schemes. How to calculate the interest. You have to pay them the interest. Everybody have a different way of calculating the interest whatsoever. So in other words, you have to look at it. There's no ready procedure to tell you which bank that you should go to. Am I right? You must look at it. You must be able to reason out which one I want to do, which bank I want to take, for what reasons. Be able to reason it out. So these are the kind of things you got to explore. How to explore? You go to different banks, all right? Asking about the details about the loan scheme. Okay, Bank A tell you, oh, this is my loan scheme, explain to you. Okay, thank you very much. I go to B, Bank B. Again, I will start the process. I gather all the information, then analyze it. Which one I should go to take my loan from which bank? Then at the end, you're going to decide which bank should I go to. Can give me the best deal for my housing loan. So these are the processes we're talking. This is called a problem, by the way. So problem is not some easy like 2 plus 3. That's not a problem, by the way. It's a problem. It's a skill. Okay? So in other words, the focus of problem solving is on what? Discovering and develop what? New solution process. You have to discover. You got to develop something new. I've never done before. Let me try out and see what that is. This is called problem solving. Then that's the main focus of problem solving. So, types of problem: non-routine problem, open-ended problem, or some unfamiliar situational problem. These are the kind of problems that we have in mathematics. Okay, now let's look at it further. I give you this mind map about problem solving. Now, first of all, when it comes to problem solving, the student comes to problem solving, they must have certain content knowledge. It must be there. I don't care what that is. It can be fractions, it can be ratio, it can be percent, anything. Am I right? There must be some knowledge there to come with them. And the problem usually is not so easy. Easy is not a problem. Easy is just a task, simple task. Okay, move this table to here. Move, don't do things very hard, just move. Am I right? So that's not a problem there. So not so easy problem. Now, so when you have a content knowledge, you face a problem, something not so familiar, not so easy, that's where you come a problem there. So that's why I want to solve it. What do you need? You need 2 things. You need a process. How to go about doing it, number 1. You need tools for the process. Okay? Now, if I want to put a screw onto this wall here, Okay, that is a job I'm supposed to do. I put a screw inside this one, so I decide, okay, which part should I be here or there? So I put a screw there. Then decide what the size of the screw, big or small. So decide, okay, then what to put a screw there? How to put a screw there? You hammer it in? Not so. Maybe you'll find a screwdriver to screw it inside there. Am I right? Now, again, the screwdriver is a tool. And again, there are different sizes, though, by the way. It's not one size, right? The screwdriver. So what size of the screwdriver that I need to use to screw this screw inside the wall? So you need a tool for the process. The process is put the screw inside the wall there, but you need a tool to do it. You can hammer with your own hand. Come on, your hand will get hurt. So these are the kind of things you need these two things. The process I'll talk about. These are the 4 steps later on, okay? And the two, basically, you call the thinking skill and strategies. Now, that's where I will focus on most of the part for today and later on in the afternoon, a lot on this one here. There are some examples. So how these two will go hand in hand. That's the whole idea. Now, talking about thinking skills. These are very basic thinking skills. All must have. Comparing, organizing, observing, sequencing, classifying, visualizing, analyzing, part whole, connecting, reasoning. These are very basic. All the kids must at least build a basic thinking skills here. Do you know what it means? Any words that you're not sure what it means? You know how to, what means comparing? Means what? Comparing means what? Compare, yeah. So what to compare in mathematics? Come on, what to compare? Big and small. Right, big and small. Remember, there are 2 words or 2 phrases they will learn. More than, less than. That's comparing. We use a lot, even in grade 1. Who has more? How many more? Who has less? How much less? You tell me. Comparing is important. So, how to organize information? In problem solving, you need to organize information. Put into whatever table, form, whatever meaningful I can use it. And the higher grade, even more so. Be able to organize information meaningfully. Okay? Observation is important. What's observation? What to observe? At the higher level, about grade 5 or 6, they look at what? Number patterns. In sequence, number sequence. I recognize the patterns, how it looks like. This whole idea. I give you 2, 4, 6. Next number, say 8, 10. They will tell you that I see the pattern. It's increased by 2. So this is a pattern recognition, number 1. Another area, where do you say observation? Geometric shapes. Problem having to see. They will write. They will know that this is an isosceles triangle. Am I right? They can see that. Okay? If I put it this way, or maybe the 2 angles are equal. Am I right? Oh, this is isosceles triangle. But sometimes, if you turn your triangle this way, then they can't see already. One thing about geometry, we talk about the orientation of the shape. Same shape, but you turn around, upside down, turn left, turn right, whatever that is. Kids sometimes have difficulty recognize it's the same shape, but only in a different orientation. That's all it takes. So, observation is important. Okay, so these are the whole idea. Now, there are lots of things here that, never mind. I will apply this when it comes to the problem solving, then you can see which one I'm talking about. These are very basic thinking skills that they must develop, number 1. These are the higher order thinking skills. Now, that is where analyzing and synthesizing. What do you mean by analyzing the word? What do you mean by analyze? I say, analyze, what does that mean to analyze? Can you put in a simple word? Is it too big a word for the kid? Does it analyze? Look through all the angles, okay? Yes. Now, in layman's terms, you take something, looks so complex, you analyze it, you break it down. into small chunks or small pieces of information. Break it down. Because I cannot see so many things in one go, I break it down. Just now, remember when we do the arithmetic calculation there? Number bond is to break it down. Big number, I don't know how to handle. I break it into small, I can handle. That's all. I cannot multiply too many digits in one go. I break it down using boxes. Analyze it, I break it down. So kids already learn how to break it down, how to analyze. That's a skill they learn. But we never tell the kids, oh, by the way, you analyze it never, okay? We never use the word analyze. But for us, we know that process of using smaller numbers from a number bond, whatever it is a form of analyzing already. You follow me? So these are kind of thing. Now, what's this word here? Synthesize. It's the reverse of analyzing. You put back together. Listen. They say, why must I break down and put it all together? It's a waste of time. No. You break it down, you reorganize it, you put it back in a different way, into something more meaningful. I can see what's going on. That's the whole idea. That means you reassemble it in a way, I look at it now, it makes better sense. That's the meaning of synthesize. Okay? I think these two look very familiar. Critical thinking, creative thinking. I talk about metacognition. Or these skills, that's what I talk about it very briefly. Now the last one, lateral thinking. I think so far in our education system, we never developed this skill. And it's okay, because this skill somehow is not required even during the exam or test whatsoever there. I checked through all the way, even up to the IG level. They never test you on lateral thinking. So even though I put it there, this belongs to a higher order thinking skills, but it's never been used in our education system. I don't know why, or through all the years there. It's been used in outside. You can use the business. Yes, business we use a lot of this thinking. So in other words, people learn these skills only when they step into the working life. When it's, oh, I need this kind of skill. But school never teach them about lateral thinking. So I'm going to waste time here talk about lateral thinking, because you teach the kids that they will never get to use it when they're young. So no point talking about it. Okay? So I just leave here. Now, these are the higher order thinking skills. These are the basic thinking skills. But how about problem-solving strategies? By the way, problem-solving strategies, I also call it, it's called the heuristics. That's another term that we use it, okay? It means the problem-solving strategies. So when I use the word heuristics or problem-solving skills, they are the same words, okay? Same thing. Now, these are the kind of strategies that they can use. Solve a simpler problem. Sometimes when they cannot handle a problem too complex, they solve a similar one, but simpler problem. That's one thing that they can do, okay? But eventually, they will have to go back to the original problem, though. I don't mean they solve the same problem and that's it. No. They use that to understand what is in the more complex problem there. They still go back. They must go back to the original problem that they're supposed to solve. Put it this way. This is only a strategy. You follow me? So this whole idea. Or use a table. Table is very good because actually, if you look at just now, I use the boxes there for multiplication. It's a table. Actually, it's a little table. I can just organize those numbers inside the table. See, once you have a table, you have to organize. I organize those numbers in the box there. You apply the thinking skills, you apply the strategy. It's called use a table. Help me to understand what's going on in the process of multiplication. So use that. Use the equation. There are lots of number equations that they use, especially in the higher grade, in a grade 5 and a grade 6. Use equations there, okay? I just look for pattern. That's important. So look for the pattern there, okay? Draw a diagram or model. Model you know already. You're going to learn about the bar model. So it's a pictorial representation of a problem. I draw a picture to present the problem, okay? Proportional reasoning now. That is one important skill they have to learn. It's a proportional reasoning. You know what's proportional reasoning? Okay. You bring the kid to the supermarkets. They look at it. Bag of apples. Okay, 5 apples there in the bag will be $2.40 for 1 bag of apples. The question is that if I want to buy 10 apples, only 2 bags, how much should I pay? 1 bag is $2.40, I times 2, $4.80 for 2 bags for 10 apples. So the more you do, the more you get, the more I have to pay more. Fair enough. And 1 apples, I pay a higher price. Fair enough. But they must do proportionally. So that's called proportional reasoning. And that's important. Where is it used? Now, I give you this example here about, like, in the supermarket. Another thing they will say proportionally is where? When they learn fractions. They have learned that 1/2 is the same as what? 2/4. Am I right? It's the same as what? 3/6. 4/8. We call this what? Equivalent fraction. Am I right? You can see what goes on. It's a form of proportional reasoning, and they need that. Form of reasoning, okay? You have proportional fraction, you have proportional ratio. Same thing for ratio at the grade 6. So these are the kind of thing. Develop that kind of reasoning skill. Logical thinking. Apply logic. Now, logical reasoning may not have numbers, by the way. I will show you later on one of the things about logical thinking in the mathematics. That means you can do reasoning without numbers. No numbers, just reasoning. Why so? There are situations where people reason things out without any numbers. That's why you need the logic to do the reasoning, okay? Working backward is quite effective. Now, one of the good skills is to learn to work backward. And one thing about the mathematics, when you solve a problem, you solve from the end to the front. Right? You're supposed to go forward, I go backward. Go backward, I'll come up to this side. Okay, so that is what I'm talking about. Okay? Then from there, I can go forward. I know how to go there already. Have you ever done such a game? Those people who draw a maze. The maze. They play the maze. That's how they have an entry point, right? Then the exit point. I want to go for entry point, find a way, away to go to exit point, right? How many kids will do it? They go the other way around. They go from the exit point and go back to the entry point. Am I right to say that? No, backward, they go backward. This is the kind of a thing that we do in mathematics. We do backward. Okay? Divide and conquer. Sometimes the problem is too complex. I can't handle it. I break it into small cases. And I tackle that one by one. That's called divide and conquer. Okay? Or you may organize list. Sorry. Okay. Anything wrong? Okay. Okay? I'll carry on. Okay, sorry. So, you organize something, a list that something, it makes sense. I'll show you some of the things, what I mean by all those terms, you don't worry about it. Use symmetry. Now, many things have symmetry. Symmetry is a very good way in learning mathematics. Many times when they learn symmetry, shape is a very good way of doing. I've ever done this. One of the games that you can do for symmetry, they use the ink. If you look at the butterfly, look about the same, right? Both sides, left and right. So they will draw half a butterfly on the ink there. They have a piece of paper, right? They draw on one side. They fold it. They open it. They got a full butterfly. Because the other side is basically the image of one side is called symmetry. They can see it. No. That's one thing which I have done it for the shape. I've given the young one, with a shape, half of it, I will give them this shape here, for example. I wanted to complete for me to this shape. Now, some they may not be able to do it. What they will do is this, very cute. I give them a mirror, they look at a mirror, put it here, they will look at it. They see the other side, right? Once they see the other side, they know roughly how to shape. They know now the shape will become something like this. You see that? They begin to see it. So that's how they use a mirror to see it's a mirror reflection. This is called the symmetry. It applies in drawing shapes, but it's not only shape, even in problem solving. There's something you can just repeat you can repeat because it's the same pattern that you can do it that way. So symmetry is a very good strategy that you can do it. Guess and check. Guess and check is another term where you always use it what? Try and error. Now, that is a strategy, by the way. But let me tell you, that strategy is the last I want to use. When nothing works, I will do it by guess and check. It's not a wild guess. It must be an educated guess. It's important, you know. I don't feel that I try this number, I'll try to, anyhow randomly, it doesn't make sense. It must be an educated guess. I will show you one example where I use a guess and check. There is a place for it. But what I'm trying to say is that guess and check a strategy which I will use a bit more judiciously. And this I won't use it so freely all the time. If anything, don't guess and check, no. I try everything else. If everything else fails, nothing works. My last resort is guess and check. That's all I'm doing. Fair enough? Because if you start doing it this way, you know what happens? It takes a long time. They may not even get the answers. Am I right to say that? Okay. Act it out. Now, act it out is a very good way for the young one to learn. They act it out. Word problems. If you have word problems involving people, like a boy and a girl, you know, maybe you have a boy and a girl there. It's a word problem there. Come forward and they role play the word problem. They give money to each other, or they give oranges, apples to each other. See how things will add together. So it's a role play. To role play, they act it out. Actually, the bigger kid, there's also a way to act it out. I've done it even for the secondary students on mathematics. Act it out. They will act it out then and see how it's being done. Now, think aloud is another way. Think aloud, I have used it before. In fact, I also use it sometimes, meaning that as I think, I verbalize what I'm thinking. I just say, I'm not sure whether you do it. When some people just do it, as they think, they just verbalize it. It's a way to help you to rationalize your thoughts. Somehow, if you do it that way, it's good. The only thing I would tell the student, yes, it's good to do the thing aloud, but please don't do it in the classroom. It's too noisy. You start thinking aloud, then the whole place is like a pasar, am I right? Lots of noise there. So, but when you do a thing aloud, please do it at home by yourself. Yes, go ahead, do it at home. I don't blame you. But in the classroom, don't do that. But it's a good strategy though. I use it myself at home. Sometimes I do my work, I'm thinking about, I will just say it out, verbalize it, you know. I will say it somehow. It helps me to understand a lot better. So these are the kind of problem-solving strategies or heuristics, okay? Okay, yeah. So these are the kind of thing, you know, we were talking. So therefore, in terms of problem-solving, you need both thinking skills and strategies. Now, by the way, the list here, see, it's only a partial list. It's not a complete list. Because there are many skills. This is the list that you see here. This list here you see here is the most common strategies used by students in the primary grades, even in the secondary grades also. Most common strategies being used. There are other kind of strategies, but they are not so commonly used, so I don't put it here to share with you. Okay? Clear? Fair enough. Okay. So that's why it's only a partial list, as I say. Now, what's the difference between the two? Can you tell the difference between thinking skills and problem-solving skills? Or is a picture to show that? What's the thinking skills? It's your mental tool set up there. I can't see how you compare, how you analyze, how you synthesize. Am I right? I cannot see how you think. I can see how you do reasoning. It's a mental skill. It's a mental tool set up there. But how about strategies? Something I can see. When you use it, you draw a table, I see your table. You draw a picture, I see your picture. Am I right? You draw a bar model, I see your bar model. Something visible. I call it a visible tool set. Okay? It's like all these tools here that you can see. I can see everything here when I use it. So these are called the visible skills. These are the strategies. So this is thinking skill. These are strategies. Make it very simple. I make this comparison here. Fair enough? Okay, I think we're here. You want to take a short break before then we go the lunch about 12. What do you want? You want a short break before I go on? Okay? Or you want it to go on now? Come on. What do you prefer? You want a short break? Don't want break. Sharon has 60 sheets of origami paper. The color of which is either pink or yellow. Okay. And she gave to Chloe 29 sheets. After giving, Sharon left with 20 pink sheets and Chloe 15 yellow sheets.
Okay. There are just so many steps. I found it hard to explain to them in the simplest way.
So the question is that, so do you know that there will be two types? So you know that there's two types. Before we talk about the color, we look at the number of sheets. That's the first thing. Because Sharon at first have 67, and she gave 29. So straight away, you take away 29 from 27, so you know how much Sharon is left with. Am I right?
Which is this 38.
Yeah, so 58. So that part is fine. Yep. Okay. And after giving, Sharon's was left with 20 pink. 20 pink. Be careful with that. So in other words, from that one, at first I don't know how many pink and how many, right? So after they give it, then we know the number of pink left with. 20 pink. But what's the difference between this and that? First of all, it's a difference between this and that. Basically, if they were to subtract, what do they get? They get what? Tell me?
38.
38? So 38 sheets. So 38 sheets that Sharon had left with. Of the 38 sheets is left with, 20 are pink.
We don't know the yellows.
So we know the other color already.
Yeah.
So that's how you have to figure slowly. Okay, so that now we know how many. Okay, so now let me put it up this way then. So you have to do it step by step. First of all, we ignore the color first. So after giving, basically, you have two persons now. They can write like Sharon and give it to what? Chloe, isn't it?
Yep.
Okay, Chloe. So now, after giving, Chloe will have what? 29. Okay, so 29. I don't know how many here. And then she has what?
38 left.
38 left, right? Yep. But out of 38, I noticed 38, okay, left. But out of 38, there'll be 20 is pink, am I right? Yep. So this is pink. So this must be what? What color? Yellow, isn't it?
Yes.
So yellow. So how many yellow after you have that? It's 18 yellow, am I right?
Minus.
Huh? Yep. 18 yellow. So you see, as they go along, they will just, but this one I don't know what they have yet. Yeah. All I know is this one here. Yeah. Okay. Now what next? Let me see. Because I've never.
We found out the yellow. We found for A already, which is 18.
Which is 18. So A. Okay. So it's done.
Now we need to find out how many pink sheets did Sharon have at first in total.
Now what? Sharon left. Okay. Sharon left with 20 pink sheets, and Chloe has what?
Sorry.
15.
Pink, yellow.
15 yellow. 15 yellow. So Chloe has 15 yellow.
From her 29, she has 15 of it is yellow.
She got 20. She gave 29. Yeah. Assuming that Chloe has nothing first to begin with, I believe that's what it says. Okay. So now Chloe will have 15 what? Yellow. So I will know that out of this 20, this 29 here.
15 are yellow.
15, isn't it?
Yep.
15 is yellow. And therefore, the rest is what? How many rest? Because it must be
29 minus 15.
Yes, 29 minus 15, and you have what? 14, isn't it?
Yes,
so must 14 is what?
Pink.
Pink. Okay? 14 is pink. Now, what's the question?
How many pink sheets did Sharon have before giving to Chloe?
Before, this is after.
Yeah.
So before, we don't know. But before, now, before Sharon's have all this together, am I right? So what they need to do is to put all things back for Sharon. So now they can see that, I put together, I know how many yellow, how many pink. Then the question can ask how many yellow they have or how many pink they have. So they must go backward, in other words. This is what we call work backward. The kids learn how to work backward. That's the whole idea about this question here. It's one of the strategies which I talk about. So this you have to. So first of all, the way to help the students understand, ignore the color. Just know how they break up the number of, Remember that's how I look at it. We look at the color first. 67, okay. 29 go to so and so. Assuming that Chloe has nothing first, okay. So that's easy. So okay. So now Chloe has 29, then she has 38. You see, the good thing about this, the total sum of all this before and after remain the same. Never change. That's key idea. When I give something to you, but the total sum is still remain unchanged. That's the important idea. It's not as if I add something more to it. That's a different story. Now in grade 6, yes, they do add more to it. Let's say a farmer have chicken and ducks. After I sold off so many, I buy in so many new chicken and ducks. That's a different ball game. But this one is no. It's just passing around. So the total is still the same. So it's the same. So everything that Chloe has, that means initially is also what Sharon have at the beginning. That's what you have to do it step by step. Yeah, I know it's a bit challenging for the grade 2. Yeah. So you have to help them to understand this. First of all, ignore the color. Just know the number first. Okay? Yeah. Then after you break it down, you break it into something simple. After I break it down, then I only slowly work out all the numbers there. Yes, I must admit that for grade 2, this can be a challenge. Yes, that's exactly how you should help them if you want to ask them in this way. I also don't know who said this question, by the way. This is not written by me. I never write the lower grade. I only write the higher grade. I don't do the lower grade. Maybe they think that these kids are getting better and better now, so better have such a question there.
This batch, their understanding is lower than my previous batch.
It says, every year will change, am I right? Yeah. Every year they will change. Okay, let's get going. Yep. That's a good question for the grade 2. Yeah. Okay.
Because I have to skip from 202 to 205, then go back to 203.
Okay. You're free to switch around all this. Yeah, fair enough. There's nothing wrong with switching around the modules. But the important about switching, you make sure that when you switch over to another module, you must know what are the prerequisites. That's something that they must have learned before they can go to that module there. That's important. So the prerequisite is quite important. All right. Okay. I think all you back. Let's go on then. Now, that is the problem-solving framework I want to introduce, and I'm going to use it. It's from Polya, George Polya. Okay? George Polya was a Hungarian, by the way. And later on, he went to the States, and he became a naturalized American citizen. So later he just stayed in the States there. Now, before he passed away, he wrote a book called How to Solve It. It's a classic book. It's by George Polya. It's by him, by the way. Okay? And basically, because the reason why he wrote this book, he found that the American students are very weak in mathematics, and which is true, in problem solving. Even until today, I think the American standards still have not gone up yet, to be quite honest with you. I think in general, come to problem solving, we Asians are better. Okay, look at the PISA, look at the Math Olympia. The funny thing in the latest Math Olympia I was watching there, different teams from different countries. You are from US, from Canada, from China, wherever they are. And you know what? I look at all the teams there from different countries. They're all Chinese. How come? I see UK also Chinese, US also Chinese. I mean, Chinese is okay, but how many other? Where's the Ang Mo? I hardly see one. So, in all honesty, I think that, Asians are better with numbers, with mathematics, in general speaking. You talk about China, about Japan, you talk about Korea, and Singapore and other places, even Malaysia that's coming up. as I said. I think what Malaysia, I think, is lacking is pedagogy. How to teach. You cannot teach mathematics the same way over a period of 10 years. No. I get the same thing today, this year is the same, next year the same. For the past 10 years, I do the same way of teaching. Actually, in that case, I wouldn't say the teacher have 10 years teaching experience. It's only 1 year repeated 10 times, that's all. There's no improvement, there's no progress. But we must understand, today's kids are very different from where they used to be 10 years, because now the internet, they got all kinds of things there. So it's a bit different. They may know a lot more than what you know, to be quite honest with you. So today's kids, not easy to handle. You can ask a question you never thought of and say, sir, how to do this one? Then you're stuck and how to handle this kind of a question from the kids there, you see. So I think, we had to change the pedagogy to meet today's challenge, so to speak. Okay, now, what I've taught you so far is only the way of doing it. But the problem is that when you go to your classroom and try to use it, that can vary. Because the student cohorts are different, even from year to year. Like if you say, last year, my students were better than this year's student. It could be. You would not know because student profile may change. So because the profile may change, the way you teach the student last year, the same method may not be so effective on this year's students. I could change it. So for the same topic, even for the same problem-solving skill, I started to do it a bit different. So that's why I never expect that what teachers learn from me, when they go to the classroom there, they may do it differently. It's okay. You can't even say, everyone must do the same way. No, I never say it must be the same way. All will be different. But still follow the same idea, but the way to do it, you have to do it a bit differently from the other teachers and vice versa, depending on the students, basically. You follow me? So your teaching style is very much depending on your students. Sometimes you have more activities, sometimes you have less activities for some of the groups. So it depends. Now, Poya come up with these 4 steps. Understand the problem, devise a plan, carry the plan, and look back. Sounds very simple, like common sense, of course. In a way, I think that Poya realized that what is so-called common sense, after all, is not that common. Nowadays, we say common sense is no longer common. Am I right to say that? Because common sense, common, I don't know. I never say that. Serious speaking, So I think that he had to relook at these 4 processes, or these 4 steps rather. How students supposed to do it? Was it understand the problem? You give what problem to the kids there? What do I understand? Sir, do you understand? He's asking, do you understand it? He said, yes. Well, you know what they mean? I've read through. I understand what he says. That's all. That is not understanding. As far as Poya is concerned, that is not called understanding. Okay? Oh, by the way, before I go on further, this book, if you want to, you can get it free of charge. It's in the internet. You can download it. It's a PDF format. Okay? By the way, when he wrote this book, he was not targeting at the primary mathematics. It's a higher level, secondary and above. But his method, his problem-solving strategy can still be used in the lower grade. That's what we have been using, his strategies, but for the primary mathematics. Okay? Yeah. But you can download it. It's a PDF version. Now, let me give you this word problem. Oh, lots of words here. Now, let's say this is a word problem your students are supposed to face. Let's read it very carefully. Okay? Samantha wants to buy a bicycle. The bicycle she's interested in costs what? How much? $420. So she had $60 saved up in the piggy bank. Okay? She got $60 in the piggy bank. But her father agrees to give her twice the amount of her savings. Now, that's important. Okay? And to make up the shortfall, that means what is not enough called a shortfall, Samantha takes up a weekend job back in McDonald's, okay, but a weekend job, where she earned $28 per hour. So she will make enough money to buy the bicycle. How many hours does she need to work to get enough money to purchase the bicycle? Oh, lots of things here, am I right? The kid was, want to buy a bicycle, want to buy a bicycle, then the father also will come in and she has to work. All these factors, so many how to do it. Now, when George Poya talked about the first step, what's the first step? understand the problem. Reading through the question does not constitute understanding. That's important. That's what I read through. Yes, I know what it says, but that's not understanding. The first thing, be able to pick up all the key information. So what you do, you high up, you see, there are too many words there, right? The kids are very bad with words. So you say, okay, don't worry about, take away all the words that you think is not so crucial. Pick up all the key words. What's the key word? Bicycle. Am I right? The key word is bicycle. It's important to buy a bicycle. The cost of the bicycle. I pick up also. So I will hide it out. I gray out here. They can cross it out if they want to cross it out. Okay? I pick up the word bicycle. Cost $420. He save up $60. Don't care whether it's a piggy bank or under the drawer. Save up $60. That's the savings. Okay? These are not important, whether piggy or no piggy bank. That's not important. Then the father, okay, what? Give her twice the of her savings. Oh, that's important. Twice the of her savings. So that's important. And that's important what? The earning per hour. Because you're going to work, right? Okay? Then question what? How many hours? These are the keywords. You follow me? The rest, they can just hide it. Once I have it, I will jot it down. You call now. That's what I said. I pick up all the keywords and I write somewhere. Very nicely. Bicycle, $400. Amount she has is 60, but father gives so much. Am I right? I can just jot it down. Then she worked $28 per hour. What's the question? 100 hours. Now, I summarize this whole thing by pick all the keywords and I just write somewhere, on my A4 size paper, whatever that is, I may just write in a corner, for example. Just write somewhere here. This is called understanding. So, reading through a question does not constitute understanding. Now, once you have that, the next step is what? Devise a plan. I must have a plan. What to do now? Now I know these are the key information I pick up already. What should I do with the? I'm supposed to what? How much money short? Am I right? I know how much money am I short? I must know first thing. And then divide the shortfall by number of hours. Am I right? So because I know by 28, okay, to get the number of hours. So this is a strategy which I have. Fair enough? That means that before you solve it, you must have a plan for it. This is my plan. It's like a battle plan. How to fight a battle? I must have a battle plan to fight. Else you know how to fight a battle. You see. So okay, I must find out how much money short. Number one. How to find out? I must be able to find out my shortfall. Okay, the money which I don't have enough, and I will divide this by 28 now. So that is my strategy to get the number of hours. So what's the next step? Remember, third step is what? Carry out the plan. Remember that? Understand the problem, devise a plan, and carry out the plan, the third step. Follow me? Now, how to carry out the step? Well, I must find a shortfall, right? I must find a shortfall. Amount short, the amount short, not enough. Must be bicycle cost, take away her savings, take away the father that's giving her. Am I right? Then left with 240. This is where you do the working. Then she must work what? 240 divided by 28. Fair enough. What? With every hour, every hour she make $28, right? So well, it's 8 and 4/7. Now be careful. That is not the final answer. Because when she work, it must be on an hourly basis. The boss never pay by a fraction of the hourly rate. So in other words, she must need what? 9 hours. Not 8 hours, by the way, but 9 hours. That's important. So this is the answer, by the way. So correct. That's the way that she analyzed it. That's how she got it. Now, many students, after they got answers, they happily turn into the teachers. They never bother to check, is the answer correct or not correct? So therefore, the fourth step is what? Look back. Please, must look back what you have done. So my question is now, is it going to, let's get the kid hesitate. Should it be 8 hours? Should be now. Not sure which one is correct. Maybe it's 8 hours. So what they will do is they will look back. They do the calculation. 9 hours. I work it out. Is it correct? I work it out. Okay? I will work it out for 9 hours. So to see whether that's enough to pay for it, 9 hours, okay? 9 hours, I work it out. So 60 plus 120 plus 9 hours times 28, I got $432, enough to pay for it. Can it be a bit less? I work it out for 8 hours. Same thing. Hey, not enough. Because the bicycle costs $420, not enough. So therefore, 9 hours is the correct answer. So that's a way to look back. To make sure that, you see, once you've done this one, they'll for sure know that, yes, my 9 hours must be correct. It cannot be less than 9 hours, in other words. And that's a good thing. Some kids may happily just give down, 8 hours, or 8 and 4/7 hours, totally wrong. It's only exactly 9 hours as such. You follow me? So that is the way. You see how the 4 steps are carried out in this way. And the last one is always good because they make sure that what the answer they have is correct and reasonable. Okay, look back does not mean that you go through the same process again. You know why? I would never advise look back means to go back to the same process again. Because if you look at the same thing what you've done over and over, they may still miss it. We have our own blind spots, we may still miss it, okay? We do it in a different way. So we work out in this way, it's totally different. I go reverse, okay, find out whether 8 hours is enough or 9 hours is enough to determine whether my 9 hours is correct. Follow me? That's how you do it. Now I'll show you some more example. Look at this question here. This is a shape. The figure below is made up of 8 equilateral triangles. All right? These are all equilateral triangles of different sizes. The length of the AB, this line here, is 35 cm. What is the parameter of the figure? Now let me ask you, where is the parameter? Am I right? Does it include this line? No. They join together, right? So that's important. The parameter is only the outside, not the inside. Inside, so this line totally had nothing. You follow me? So that's important. So first of all, the kids understand the word. What's the parameter? It's only this line. This is called parameter. Am I right? Inside doesn't count. If any line here inside, whatever line which I have here, doesn't count. It's only this one. Am I right? This is called the parameter. So it's only out here, outside. Okay. How to find? You are only given information for this one line only. No. The first thing is step 1, understand the problem. What they should put down? Put down anything else. 8 equal triangles, that's what it says. The line AB, 35. Find the parameter. That's what it says, all right? But something it never says. Do you see that the 8 equal triangles also got 4 rhombuses? Because each one of them is a rhombus. Am I right? So you see there are 4 rhombuses. Every 2 equal triangles put together form a rhombus. So I see 4 rhombuses. Okay, good. 4 rhombuses. Now, that is now. This one is not given, by the way. But they can deduce one has been given. That's important. But even kids don't see the 4 rhombuses, they can still see the 4 or the 8 triangles. The reason why I say I put it this way, because it will make the calculation a bit easier. That's all it takes. Okay? Never mind, but even if they don't see it, they can still solve the problem there. Devise a plan now. Sum of one side of each of the 4 rhombuses is 35. Am I right? Now you got 4 rhombuses. Now, what's a rhombus? The sides are all equal. Am I right? And this is an equilateral triangle. So they say that the sides of all these four rhombuses, one side only of this one, okay, is equal to what? 35. Am I right to say that? Because this is all because they make up equilateral triangle in the first place. Right? So all the sides are the same, right? So one side, this side, add together is the same as this line here. Am I right now? So that's I can see it. Okay, so I will divide this plane. Am I right? No. I take one side, add together this side here, it's the same as 35. Why? Because all this side is the same side equilateral triangle, so they can see it. Okay, now I know this. Okay, good. So now I know how to calculate the plan. Because I know that if the sum of one side of each of the four rhombuses is 35, and know a rhombus has how many sides? 4. Therefore, the parameter must be 4 times 35. And that is the parameter I'm supposed to find. That's it. Very straightforward. How to look back? You take 140, you go and divide it by 4 to see whether you get back your 35. Am I right to say that? You look it back by this way. That means it must be the same as this length AB. So when you look back, the length of AB must be equal to 140 divided by 4, 55 cm. So therefore, I know that my answer is correct. That's how you do it. Now, see, 4 steps. Apply to word problems, apply to problem on shapes. Hoyas, basically, the 4 step apply to any kinds of problem. Of course, we use it more often on the word problems than on other things. Because why? Word problem have too many words for the kids, by the way. They read a lot more, okay? Shape is only very few words. But you see lots of shapes given them. But as I say, even then, Hoyas 4 step can still be used on the question on shapes. Fair enough about the 4 steps. I'll just demonstrate the 4 steps, with examples. Okay, we had a break already. Now, where to apply problem-solving strategies? Just now we talked about look back, make a table, remember? Solve a simpler problem. So we look at where to apply it. And I say that usually you apply it in step 1 and 2. Usually, I would say 1 to 3. These are the places where you use the problem strategy more often. For the step 1, strategies are used to enhance understanding of the problem. It helps you to understand the problem better. I can draw a diagram to represent some of the things, some of the words in the word problem there. I can do that, right? And have to organize information. I can use a table to organize what's given to me then. So this whole idea. And then once I can organize it using a table, for example, then I can identify relationships, how things are related to each other. Table is a good way to see relationship, by the way. Okay? Yeah. And also be able to uncover what's being implied. Just now, remember, I have discovered they form rhombuses. But the question never talked about rhombus in the first place. But once I look at it, I say, actually I got 4 rhombuses instead of 8 equilateral triangle. So that's how they would see it. So therefore, you can also uncover what's being implied from the given. That's what it means. Now, you also apply strategies in what? To map up your action plan. How you want to do. So that's the whole idea. So this step 2, devise a plan, is to help to map out your action plan for step 3. This is where you use the strategies. When it comes to step 3, it's purely execution. You carry out the process already. You got a plan, right? You carry out the process. Now, one thing I want to tell you, when the kids have a plan, have strategies, when they carry out the plan, does it mean that it must always work? No. Somebody got a plan, very good. I do it. Halfway I get stuck. Hey, my plan doesn't work. My strategy doesn't work. How? Teacher, I don't stop it, you do it for me. No. What they should do is that if that's the case, they have to go back to step 2. Backtrack. I may miss out some of the things there, which I failed to see, number one. I have to change my strategies. Maybe this one I think of initially is not the right one to look at. I change to another strategy. There are many strategies. You will see the list of them. I change to another strategy. Even sometimes I'm going to go a step even further to back to step one. Maybe I didn't fully understand the question. I missed out some of the key information. I missed it out. I look at it again. So in other words, Poya's 4-step is not a one-way street. You can go backward, then forward, backward and forward, backward. Yes. So don't take it as one way. So be careful. So they can go backward. All right? So that's how you use it. But you need to have a plan no matter what. If you solve a problem without any action plan, chances are you make lots of mistakes and you know where you make the mistake also. So that's the reason why Poya are very particular about this use of the strategies there. Step 1 and 2, use most of the strategies. Now let's look at this one here. There are 30 people at a party. Each one shake each other's hand once. And only once. Shake your hand, only once. How many handshakes are there altogether? That means if I shake your hand, that's it. We won't shake it anymore. So shake hand once. Now there are 30 people. How many handshakes altogether? Wow. How do I count? It's hard to count for 30 people, right? How do I count? How many handshakes? So what you do now, just a strategy here. Okay. I use what? I solve a simpler problem. And I use the table to do it. You see, I combine now. When you strategy, you can use 2. Not only 1, you can use 2 or 3 if you want to at the same time. So here, I want to solve a simpler problem. I can handle 30. There's so many of people there. Can I handle a smaller one? For example, say, I want to have 5 people. I use a table. You see that? And I count number of handshakes. So I will count. Okay, I call it A, B, C, D, E, 5 people. Or 4, it doesn't matter. Someone can use 4 or 5, it doesn't matter. I use 5 here now. 5 people, they shake hand. Okay? Of course, A will not shake his own hand, obviously. Shake other people's hand. So I will see that A will shake B's hand, one take. So A will shake hand with what? C, D, E, right? You can see that. Now after that, I come to B. Now B, since the shake hand, have already done that with A. So there will be no handshake here, right? So there's nothing, only once. Of course, B will not shake his own hand, he will just go on to shake the others. You follow me? Then same with C. So C will only shake D and E. Am I right? Because this has been done already, so he doesn't do it anymore. And when the D, only shake E's hand, and that's the end of it. How about E? Shakes no hand. It's all done. His hand, the shake of hand, then that's it. So you look at the number here. How many handshakes? 4, 3, 2, 1. Very nice number. For 5 people. A, B, C, D, E. 5 people. These are the number of handshakes. How many? 1 plus 2 plus 3 plus 4. What's the answer? Who can tell me? 10. No. Okay. So you see that these are number of handshakes, right? Do you see this as a pattern? There are 5 people. The total number of handshake is that many. You say, well, how many? 10 handshakes, right? I don't see 10. I see what? It's a 1 plus 2 plus 3 plus 4. Now, you can see what I'm looking at now. Now I can go back. So number of handshakes, what? 1 plus 2 plus 3 plus 4 is equal to 10. I see that. So from here, I can see if there are 30 people, how many handshakes are there? Look for a pattern. You see that? I see when there are 5 people, I only add 1, 2, 3, 4, up to 4. So if I have more people, I'll go to 29. Am I right to say that? Then I work it out, it'll be that many. Now, when it comes to this one, if the poor kid would add 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4. I tell you what, Until go to 29, I think the kids are exhausted. Don't ever do that. Try to be smart. Okay? So what I do basically, I pair them. You see, I'm doing the pairing now, see? I pair 1 and 29 is what? 30, right? 28 paired with 2 is another 30. Am I right? So I go all the way in. You follow me? I get 14 pairs. I got 14 pairs. But only one number has no pair, the one in the middle. That number is what? 15. You with me? Yes. Question. Okay. Hello. How the table works. Okay. All right. Okay. The question from the online user says, how I use this table? Use of table is one of the strategies. We use it to organize information. Because table help me to see how information can be organized so that I understand better what is going on. So that's the reason why I use the table. Because from the table, I can start counting number of what? Handshakes. So that is the purpose of the use of the table. Okay? And I start with a simpler problem, meaning I start with only 5 people. And then from there, I use the table, help me to organize the number of handshakes that it can take place. And that's why I come up with the table. And when I tally up the number of handshakes, I see that it's equal to 1 plus 2 plus 3 plus 4. So that is the way we find the pattern from the table. Have I answered your question there for the online user here? Okay? Yeah, that's how it is being used as such. So I see that now the handshake among 5 people is only, I'm adding from 1 to 4, which is 10, of course. But I'm looking at a pattern, which is what? 1 add up to 4. So if for 5 people, you add a number of handshake is from 1 to 4, then for 30 people, you must add up from what? 1 to 29. If I change the question, there's 100 people in the party there. Easy. You add what? 1 to 99. You see that? So that is the way, you apply strategies. You can see that here, how many strategies have I applied? 3. First of all, the first one is I solve a simple problem. 5 people first. I use the table to help me organize the information for these 5 people. So that I can see the meaning of it. From there, I can see the number of handshakes because it's easier, there's only 5 people. And from there, I look for a pattern. This is the third strategy I'm using here. Oh, I see that 5 people, I only need to have that many handshakes. Adding 1 to 4, then that's all. Once I see that, I can go back to my original question, which is what? 30 people. I do the same way. And this part here basically is a matter of skill, that how you add together by pairing. This is a very effective way of doing is by pairing when you're adding up numbers. Okay, I hope that the online observer understand it. Hello? Yes? Is that clear enough? Yeah. Now you begin to understand how strategies are being used. Okay? Yeah, that's basically, I will show you this. Now let's have another example. Now this will have fractions. At a dinner, 3/5 of the women came with their husbands, and the rest of the women are single. So there are some single girls go for the dinner, and there also ladies go together with the husband. Altogether, there are 48 guests in total. How many single ladies were at the dinner? Now, this question is no longer having whole numbers, but also a fraction, right? 3/5 of the women. So how to handle it? Where to start? Now, of course, because of time factor, I don't go to the 4 steps. But basically, still go to the 4 steps, though, okay? I go right to the strategy part, okay? But same thing, you're supposed to organize the information, write down all those things. That's step 1, understand the problem. and then devise a plan. But just go right to the strategies now for this one here. Now, how do they start looking at this one here? I got fractions. So, I draw a picture. I don't know. They say 3/5 of the women came with their husband. What does that mean? That means for every 5 ladies, 3 are married. Am I right? 2 are single. So, I put down 3 women, these are married, 2 are single. So, for every 5, because they 3/5, so I don't know how many, but 3/5. So, for every 5 ladies, 3 are women, okay, these are the married one, they come with a husband. 2 are singles. I know that. Now, so I draw a picture. This is a strategy. Now, I use proportional reasoning. Now, that's important. I say, once I see that, I want to see, because you see, that means out of every 8 people, I will have 2 singles and 3 pairs of married couples. Am I right? But altogether, how many guests? 48 guests. Now I can do proportional reasoning. Groups of 8 is in the picture, can be repeated for all the 48. That means I can have this over. Am I right? That's basically. How many groups can I find? 48 divided by 6. Divided by 8, sorry, equal to 6. Am I right? I can repeat this 6 times in order to get 48 numbers. But every group, there are 2 singles. I can repeat this one how many times? 6 times. So number of single ladies must be what? 2 times 6 is 12. Correct? So now what's the strategy? I draw a picture. Oh, I see that for every 8 people, there'll be 2 single girls. Okay, good. Every 8, 2 single. I got 48, right? So I count. Okay, 1 group, 2, 2, 2, 2. How many times? 6 times. Then I will get 6 times 2, which is 12 single ladies. Clear enough? Okay. Any question from the online? Yes, okay, this is clear. Yeah, okay, good. Now you see how powerful are the strategies? You can really analyze such questions there. Huh? So that's the whole idea about using strategies. Okay, now go to the shape. Now this is from PSLE, by the way. PSLE stands for the Primary School Leaving Examination for the grade 6 students in Singapore. All students in Singapore must do the PSLE before they will go to secondary school. Okay. Now this one happened to be in 1923. There was just about, COVID is when? It's after COVID, isn't it? 23 is after COVID already. 1 year after, isn't it? Okay, after 1 year. So that's the kind of question they will see in about paper 2. I only show part of it. I only part A, 17 part A. Now look at it. The figure shows a trapezium with parameter 96. This is a 1, okay? Figure 1 is made up of 3 such trapeziums and has a parameter of what? 204. Parameter, don't keep the count outside, it's inside, right? Find the length of AB. Now look at it. How would you think the kids are supposed to think to solve this problem here? This is a grade 5 or 6 problem. Come on, I want you to think about it. How this starts. They want to find the length of this height, AB. And this trapezium is used to make up this shape. It's the same one, but repeated 3 times to make up this shape. How can they find it? And you've been told the parameter of the whole thing, okay, which is what? 204 cm. What do you think? You are given the parameter of this one and this one also, by the way. How to start? What strategy can I do? Okay, now. You work backward. I don't know how to do it, but I do know that what? I do know the parameter of one trapezium. It's given me 96. That's all I can do. I don't know about I don't know, what's the length of AB, but I know that at least it'll be this one. So I know there are three parameters, as if they all separate three parameters before they put together to form the figure 1. If three of them, it must be total what? 3 times 96. Am I right to say that? 3 separate, that's easy. But the thing is that these three parameters have to put together. You follow me? Put together to form this shape here. But once they put together, something disappeared. This length disappeared. Am I right? This length disappeared. Am I right? Ah, good. If they disappeared, that means I must know how many such edges disappeared altogether. Can you see how many times they disappeared? 3 times? Or say 3? 4? Hey, 3 or 4? Another question. Okay, that's a good question. Yes? Okay. Never mind. This part of the learning. We work backward now. Okay, we work backward. Now let's see. They say 4. Why 4? Where did you get the 4? Now, don't forget. This one got one side. This, right? This on one side. Join together, 2 disappeared. You can see that. When I join this one here, this also disappeared. Am I right? But it also covers part of this longer one, the other side. So altogether 4. So, all right? So, therefore, 4 of this length, AB, disappeared. Am I right? And that is equal to what? 3 separate one. Take away what? The parameter of the whole thing. Fair enough? Which is 204 become 84. So 4 of the AB is equal to 84. Now I see that the length of one side, of course, I just simply divide 84 by 4. 21 for the length of AB. That's how it's being found. Now look at the strategy here. I don't know how many. I take separate 3. When I piece together, something missing. Hey, the AB side missing. So when I piece 2 together, 2AB missing. No more, I cannot count it anymore as a parameter. When I join the third one into it, the third one, the AB, is missing, but it also covers part of this trapezium here, right? So actually there are 2 AB missing the length. So that's why it is 4. And once they figure all this thing here, they just work it out. So the strategy used is called what? Work backward. And this is our PSLE question, and it's only part, because it's only 17 part A. Not full question here. I can't remember. I don't bring this question into your adjusted yet. Maybe later on, yes. Okay. All right. What do you think? Is it very hard? But you see, the whole thing about strategies, you was able to reason backward. Am I right? I used the 3 separate trapeziums. I walk backward in order to do it. Okay? So that's the whole idea about solving problem. Now another one. This was a very typical kind of a question. Counting what? Number of chickens. Okay? Using the legs. Okay, now there are altogether what? 30 chickens and goats. Now, chicken and goats in the farm. Goats and chicken all in the farm. How many animals there? 30 of them. Okay? And you count number of legs, 100 legs altogether. Find the number of chickens and the number of goats. Of course, kids should know very well. Chicken only have 2 legs. Goat has 4 legs. Don't give me a 5 legs goats and a 3-leg chicken. Okay? Okay, that's easy. Now, how to do it? This one. Counting legs already. Oh, by the way, Having said that, this type of question, when it comes to secondary, is very easy. You know why? They can use algebra to do it. But our dear primary so far, whether unfortunately or fortunately, they only learn algebra in grade 6, and only one module, 601. Oh, by the way, that 601, I was asked to move it to do it a bit later, not as the first module for grade 6. Kids find it difficult to understand algebra. So I said, can you please move that a bit later in grade 6 to learn algebra? Okay, I agree to it. So I think eventually that 801 will become, I don't know, 805 or 806, I don't know. I let the agency people handle that one. I say, okay, you can move it around. So that means there will be reshuffling of the order of the module for grade 6. But still be there, only one module for algebra. Okay, the focus in the primary is not so much on algebra, it's more of the thinking skills. The price strategy is the whole idea. Now, how to do this one then? We're going to find the number of chickens and number of goats from the number of legs there. I'll use the table again. Now, table is very good, but help me to organize it, right? Okay, you see? Easy. Number of chickens, number of goats, number of legs. What more can I expect? That's all. I took a chicken and goats and legs, and what else do I have? I've got nothing else already in this question here. So a table to use to organize it. Now let's see. Guess and check now. That's why I use a guess and check. I don't know how to count. So let's use a guess and check. Now, let me start with the first guess. I may not be right, okay? Let's say I got 30 animals, right? I start very easy. 15 chickens, 15 goats. Easy. Then I count number of legs. How many? Work it out. What? 90 legs? Not enough. Am I right now? Not enough. There are 100 legs, right? So I must have more. Now, should I have more chicken or more cow? That's important. Now, that's a guess and check, right? So therefore, guess and check is not a wild guess. It's an educated guess. I'm talking about, should I have more chicken or should I have more goats? Now, don't forget, when you add more to one side, you have to take away some from the other side. But total is still what? 30 animals. You can go beyond 30 now. Let's see. Okay, so you want to put in more chicken and less goats, or more chickens and less goats. So whichever way you want to do it. Now let me try. How about I increase number of goats? So I put 2 more goats there. So 15 go to 17. Add 2 more goats. 17 goats. Then I only have 13 chickens, right? So therefore, I slightly guess it. 94. Oh, okay, good. But still not 100 yet. So I can keep on doing it. Oh, good. Now come to 11. Okay, come to 98. 2 more goats. Then the chicken will be less by 2. So we have 11. Work it up. 98. Now, very close already. Am I right? I need 100. So, what can I do? Can I add more goats and less chicken or what? I do not know yet, but let me see. I add one more goats, so I'm going to take away 1 more chicken. I work it out. I get exactly 100. Now, by the way, I want to show you these 4 lines. But when the kids do it, it can many lines. Because they play with their numbers there. You follow me? But no matter how they do it, eventually they can only get to 10 chickens and 20 goats in order to meet the requirement 100 legs. That's how to do it now. That is where, when you have no choice, you use the guess and check. It is not a wild guess, educated guess. And you just fine-tune your guess step by step. Whether you want to increase more chickens or you want to increase more goats to balance out the legs as such. Okay, I'll show you some of these strategies here. I think, so that you can see that. That's it. That's the answer. 10 chickens and 20 goats in the farm. Okay, now let's just play this game here. Cheryl's name, okay? Her name. And she starts counting the letters in her name in the zigzag manner. So start counting in this way. Cheryl. Then start counting 1, 2, 3, 4, 5, 6. So come back here. Should go down one level, you count backward from right to left, but start not from here, but from here. Okay? 6, 7, 8, 9, 10, 11. Down here, he starts from the next letter, 12, 13, 14, 15, 16, 17, 18, 19. So you know how she count? Zigzag, eh? The question is that, in which now, this first row, second row, or this row, in which row is the 100th letter? And what's the letter? First of all, in which row is the 100th letter in the way that she's counting? And what's the letter now? You figure out. She counts in the zigzag manner. You just do it and see what happens. Tell me, which row is the 100th letter and what is that letter? Don't tell me to start counting all the way to 100. You have a smarter way of counting now. This is a counting problem. Yes. How do you count it? You want to count 100 letters. You tell me how you count. That's important, okay? Not so much what's the answer, but how do you do the counting? Okay, have you figured out? Anybody? Raise your hand. Have you got it? Not yet? Okay. Have you got it? Anybody have got it? Just raise your hand. What strategy do you apply here? Tell me. Before you can you tell me what strategy are you applying now? No strategy? Come on, what strategy do you apply? Come on, just say it out first. What strategy do you apply? What are you looking for? What are you looking for? Give a name of the strategy. You're looking for what? Look for a pattern, am I right? Yeah, of course. What else do you do? That's the only thing. Look for a pattern. Seriously speaking, look for a pattern. But of course, there could be different views of the pattern. There can be different patterns, by the way. Fair enough. There's nothing wrong with looking at different patterns, but still look for a pattern. I said, look for a pattern. Your pattern and the pattern can be different. It's okay. Never mind. Okay, now tell me. You apply look for a pattern strategy. What's the answer? Can you tell me? E. Which row? Which row first?
20th row.
20th row. 20th row. And letter E, you're saying, isn't it?
Letter H.
Letter H. 20th row, 20th. Okay. How do you say? Same answer? How do you count? Tell me, how do you count? You can show me how do you count. How do you count? Don't be shy. Just show me how do you count. This is part of the learning process. Show me how you count.
I don't exactly know how to do the working.
No, show me how you count. This is all about counting, right? You count 100, okay? How do you count? No, how you count. How you count. You look for which. Okay.
All have 5 numbers.
Yes. Okay, good.
All of it has 5 numbers. All the first row have
6.
6 numbers.
Exactly.
So, we want to know which one is the
100th.
letter.
Yes, right. Correct.
So, I just need to find the balance. So, from 100 letter, 100 minus 6, you are left with 64 letters left.
Yes. Okay,
And
good.
94 letters left. But
Yes.
since that the pattern we have here in every row we only have 5, 5, 5, 5, 5, 5, 5.
Yes, right.
So I split this into 2 parts, 90 and 4.
Okay, number bond, eh? Good.
So this 90 we can divide it by 5.
Yes.
So we will get
18 row. Okay, good. Very well said.
80 row. And another method I use is
Good.
what I can see from the second row.
Okay. Okay, you know straight away they're all together 18 rows, right?
Yes.
Good.
18 rows for this 5, 5, 5 numbers.
Yes. Now, don't forget you have the 4 there still.
Yes.
So therefore, another row there is another row, right?
Yes.
The 4 is another row, correct. The 4 is another row, am I right?
So this
18 plus 1, 19, am I right? 1 row, so 19 row plus the first row,
20
20 rows altogether.
altogether 20 rows.
Okay, 20 rows together. How to get the letter H? Good. So the 100 letter must be in the 20th row, right?
Yes.
How do you know that it must be letter H? Tell me now.
So
You're right so far. You're right. Yes, I agree with you 100%.
so then from
How do you know it is what? 20.
no, I think here I know.
Okay. F3, you have all these, you have all together how many? 18 rows, you're saying, okay? 18, you have 18 rows here. I follow your argument, don't forget. Now, the key question is that when you get letter X, So you count from the left to right or right to left? That's the question now. Correct or not? So you must decide, somebody count from left to right or right to left. That is the question. Yes. Very well said. I agree with you 100%. So you count the four more. So where would they end? Where would it end? If you count to the 18 row first of the 18 rows, where would it end, the 18 rows?
You will end at here.
At here. Okay, at here, very well, okay? Now you need to count 4 more, right? So we go what? 1, 2, 3, 4.
So I start here.
So he must count from right to left. That's how he counts. Anybody have a different way of counting? You do the same way? Different way. Yes. You tell me how you do the counting. Come on, just come and explain. It's okay. Thank you very much. Correct. Okay, that's how she count. Never mind, it's okay. Don't worry about long or short. I just want to know about what is your pattern. That's all.
6, then 16, then 26, 36.
Okay.
46 all the way. And then, then after that it's 97, 98.
99, 100, which is at the age. Correct. Beautiful. That's how she did it. Now, what do you see? That means. Oh, no battery. In other words, if you give this to your students to do, what's going to happen? They may use different columns to do the counting. That is the beauty of it. They all apply the same strategy. Look for a pattern. Yes, the pattern can be different among the students. They are equally right. And that's how they will do it. You follow me? So that is what I am looking for over this kind of a thing then. They will look at it from that perspective. All right? So another way of looking at it is that I want to know the 100th, right, letters. So I want to look at it from, doesn't matter from this one or this one here, wherever it is. You can start looking at it from that perspective in a way for the 100 letters. So what you've done is correct. You see, she looked at it from the other way around. But the key thing at the end of the day, you must know whether you look for different. I can also look from here though. If I'm looking from here, then I must decide I must go from left to right already. So it all depends on which way that they're looking at. Yeah. You can try to your kids and see how they would do it, and then it will be quite fun. They will talk, teacher will do it this, I'll do it in another way. Fine. It's to develop, the ability to look for pattern. That's all. And they all will do it differently, and that's the beauty of it. And get the same answer. Okay, good. So look for a pattern is a strategy. Now, why don't you do something now? Okay, for your own. Now, these are some of the questions here. You can try any one of them, by the way. Okay, I give you, you can try for half an hour, not an issue there, and see which one you want to pick it up and see how to do it. Now, I want you to demonstrate Poya's 4 steps on the following questions. See how you do it, okay? We'll try and see what happens. This is the red one better, I think the red is, yeah.
I'll use number ones. Page is 6. Number ones can use 3. 3. If it's 2, 4. I can use 6, 1, and 5. So they say the ages are reversed, so it means you can't use these ones. So you can use either these. The son's age can be either 24, 22, or 15 and 51.
How could they be?
Because the ages are reversed, right?
The ages is reverse,
So
correct.
sum up to 66. So the numbers here are reversed. This one is
Okay? So there are two possible answers, am I right? All agreed? Yes. So now what the kid will see is that what? A question may have more than one possible answers. This is the first one is a good example, okay? You work out numbers, which can be reversed, am I right? So, absolutely right. Is it do the same way? That's easy, okay. How about second one? Among 88 students, 34 of them wear glasses. 1/3 of the boys and 3/7 of the girls wear glasses. How many girls are there in the class? No. Now, this is lots of information. You got boys and girls, number one. You got wearing glasses or no glasses, am I right? So, what's the best way to do it? Understand the problem. What's the best way to understand the problem? Who can tell me that? What strategy would you use to understand the problem? Come on, just shout for me. If you were to do this one, I'm not asking for a solution though, by the way. I'm asking what strategy that you want to use for a start. I told you already, you only boys and girls. Okay? Yeah, boys and girls, that's all. You know altogether how many of them? 88. And you also know that among these students, 88 of them, some wear glasses, some don't. So what is the best way to start? Now, there are lots of information given you here. What can you do? Just give me a name of the strategy. Now, by the way, this strategy's name, the label which I showed to you, like use a table, solve simple problem or thing, it's not for your understanding. You never use it in front of the students. They only use the strategy without knowing how to call it. It's okay. Okay? Now, when you're faced with such a question here, what can you do? Bar model? You can. It's hard. You have glasses and no glasses. You have boys and girls, right? A bit complicated. Don't you think that if that's the case, a table is very easy to organize information? Can you do something like this? Maybe I have this one. Boys, doesn't matter. Am I right? A lot easier to organize it. Am I right to say that? And I can have it even more, by the way. I can even have it a total. So I know that, okay, I'll fill in a blank there, okay? Altogether what? Boys and girls, 88, am I right? So I can know total must be 88 no matter what. So in other words, here must be 88, fair enough? So no matter how you add up all the things, it must be 88. Right? So I can fill this one now. So slowly you will fill up then. And they say what? 34 of them wear glasses, am I right? I don't know how many. What should I fill in this blank? Wear glasses, 34. Am I right? You see, I just use the table to organize the information. That's it. So that's my strategy. Use a table to organize the information. Okay? 1/3 of the boys and 3/7 of the girls wear glasses. So 1/3 of the boys, and what? 3/7 of the girls. So if I do that, that means I know how many. It's 2/3 of the boys, no glasses, and 4/7 of the girls, no glasses. Am I right to say that? And that's all it says. Okay, now I leave it to you. You can finish up this question. So you figure all the things here. how to work out all these numbers as such. Slowly you fill in the blank, okay? You fill in the blank. I don't spoil you, just fill in the blank and see how do you figure out eventually how many of these people here as such, okay? Now copy out this table because of time factor. I'm looking at the time. This is the reason why I can't go through all this. I go through each and every one. Give you a head start first. Then you go back and you will finish it up now. Number 3. Look at number 3. A group of 5 girls booked a computer for 2 hours. They took turns to work on the computer for their project. But at any one time, only 3 girls can work on the computer. On average, how long did each girl work on the computer? Give your answers in hours and minutes. How do you handle this kind of question? Now, there are lots of information here also, by the way, okay? You got number of hours, you got 5 girls, okay? They can book a computer for 2 hours. And they must take turn. I don't care how you do it, but they must take turn within the 2 hours to do work on the computer. So obviously, the girl can take up, each one take up 2 hours, impossible, right? Because they only have what? They can only have 3 girls to work at the same time, that's all. So how do you handle this? The question is that the 2 hours, you must work out into the time slots. Because they say that, on average, how long can they work on the computer there? So the answer to be in hours and minutes, that means what? That means you have to break it down into minutes. So in that case, I will take out what? 2 hours, 120 minutes. I break it into small little lots. And start filling out all the girls. How to fill out the girls? Each time it's only 3. Every 20, that means if I work it into 20 minutes each, how many slots do I have? 5 slots. All right? 5 slots of 20 minutes. I got 5 girls. So again, what strategy I use? The table. Time and the number of girls, right? I can do it this way. I have 5 slots. 1, 2, 3, 4, 5. So each one is what? 20 minutes, am I right? 20 minutes, all the way. Okay? All the way. It's a 20 minutes. I got 5 girls to fill in. Okay? Okay? All our 20 minutes about 20. Am I right? 20 minutes. I got 5 girls. You fill in the blank. Now, each 20 minutes, I can put only how many girls? 3 girls. So you decide, okay, I don't care what they vote, okay. You know what I say? I want to do this. And that's it. D and D cannot do. So you may put in. See how you figure it out. You follow me? So you can do, you see, I'm just using the table to help me organize the information given to me. And that's all it takes. But from there, I can analyze it and I can start filling up the table there to see how many 20 minutes that each girl can take because they all had the same number of hours and minutes. You follow me? So that's how it works. Okay? As I say, I leave you to finish up because of the time factor here. That's why I try not to go beyond that. And also I have to rush out to the airport, by the way. Yeah, to avoid the traffic jam. Okay? You think about it. Never mind if you have a problem there. You can always send me an email if you want to, or send me a WhatsApp. Okay, if you want to contact me, I can give you my number. But please state your name. Okay, but I don't know who you are. Tell me where are you from, so at least I will know that you are one of my participants here. Okay. This is my number. Sorry, my handwriting is bad. No, this is It's a 3, yeah? Okay. 92381034. This is my number. You can take it down if you want. Send it to me if you have a question on any of this one here. I'll try my best to help you. Okay, I will erase my number. I won't put it here all the time. All right. Now, what is the missing number here? Who can tell me? What's the missing number? You got 2, 4, 6, 8, then 12, then 18. What strategy would you apply? This one. Pattern again. You see, pattern is very useful, by the way. Pattern, but what pattern is the question? What pattern do you use? That's right. Okay, good. This is very good. What pattern do you use here? What pattern do you use? If you look at the increase, 2 to 4 is increased by 2, by 2, by 2. But how about the 12? If you go for 8 to 12, it's by 4. Then 12 to 18 is by 6. A bit hard, right? So how to look for the pattern? Pattern don't have to be always, must be this to this to this. Yes, that's one way of looking at the pattern, but we always look at the case here. Can I see it this way? If I can't see that, I will say, okay, if this, I jump over and come to this one, 2 plus 6 is 8. Am I right? Well, okay. Yeah. And then here, 6 plus 12 is 18. Am I right to say that? I jump over. 2 plus 6 is 8. 6 plus 12 is 18. Okay, now you figure out. What's the question mark? I jump over one number. Who can tell me what's the number? What's the number? I said 2 plus 6, give me the 8. Okay, so you see that. Okay, 4 plus 8 is 20, is 12. Okay, now 4 plus 8 is 12. Then 6 plus 12 is 18. Come on. Woo. Oh no, sound.
26.
Huh? 26, right? Yes. It's 26. Absolutely right. How to know this place is correct? This 38, right? How to get 38? 26, right? 12 plus 26, 38. So that is correct. You look back, that is correct. Let's see the 4th step, I still use it. Look for a pattern. You can check through, check back and say, yes, use 38 to confirm that my 26 is correct. Okay, good. How about the last one? Which fraction is greater? Who can tell me? Which one is greater? You mean what? This one is greater? Or this one is greater? This one? This one? Okay, okay, that's fine, but how do you see it?
Smaller number, bigger ratio.
Denominator?
Is bigger.
Okay, but how how the kid was supposed to see if it teaches kids how to learn how to solve it. You use a what?
Compare maybe 1/2 to 1/3, half and 1/3. Half is bigger than 1/3.
Half.
Example.
Okay. Well, this one's a bit different. Okay, this is the same number, right? You see the same number, right? This is one bigger than this one, right? So if I have to compare, I must compare with what? 2/3. Am I right? If I look at the pattern, I mean, look at it. If I start with 1, because you can see that the difference is always 1, right? It's a 1, so I will use difference. It's 1. So which is bigger? This is bigger, right? 2/3 bigger than 1/2. Fair enough. Okay. But of course, they have not answered my question yet here. Of course, I can see there's a pattern, right? Some more pattern. I mean, put it this way, am I right? Now let's look at some more pattern. Let's go a bit further. Okay? How about this one? I compare with what? 3 and 4. Is it bigger than this? Okay. How about if we go to 4 and 5? No. What say you? Which bigger? This bigger or this bigger? Now come on, which is bigger? Who can tell me? No answer. Hey, how come? It's difficult from there. If you're not sure, use the calculator, punch the calculator and see what happens. Bigger, right? So it seems that one is bigger. I solve a simpler problem first. That's how I would kid to see it. Can they draw a picture? Fraction got to do with parts and whole. There's a concept there. Parts and whole. Parts and whole is called a fraction, am I right? So in other words, I got a 1. I'll put this as a 1. Okay? Now, if I were to divide this 1 into 2,000 parts, so 1 number is come up to here, am I right? That's it. This is from here to here is 1999 over 2,000. So this little gap must be what? 1 over 2,000, am I right? Oh, sorry, 1. Now, if I draw the same here, 1, still 1 by the way, instead of breaking 2,000 little slots here, I bring to 2,001. So this one up to here, from here to here, is 2,000 over 2,001. And this gap must be what? 1 over 2,001, right? Look at the two gaps. Which gap is bigger? This gap or this gap? Bigger gap, right? Smaller gap, right? Smaller gap, that means what? This line must be longer than this line. Am I right? Therefore, this number is bigger. I look at the gaps. This is solving it by drawing a picture. This one, I'm doing it using what? A simpler problem. Solve a simpler problem to do it. That's how kids can use different strategies to solve the same problem. And that's exactly what I would like you to train the children to think along that kind of a mindset. But you must learn it first for yourself, yes. Then you teach the kids slowly, you know. Of course, you may not use a big number. You can use something like 199 to 200 if you want to. It's up to you, whatever that is. You can come up with some kind of a number. It's fine. Or even 49 over 50, up to you to do it. It makes no difference. It's the same strategies, you know. They can either, you know, draw a picture or solve a simpler problem just to understand this kind of a question. You see, the whole idea about problem solving, you can see that it's applied thinking skills and using strategies to do it. That's all. You don't do it by heart. You say, do I learn it by heart? I never do it by heart. Okay. All right. How do you find so far problem solving? Is it interesting? Is it too hard? Slowly, you had to get used to it eventually, okay. Last time, did they train you in the university there, this kind of way? Are you trained in this way?
Not really. I just been teach on how to deliver the pedagogy, but we still didn't master it.
They know about strategies, eh? Okay. But the important thing is about strategy. These are the kind of things you do. Now talk about pedagogy, how to teach. Absolutely right. How to teach now. Now you know the strategies. Now you know the thinking skills. But how are you going to deliver to the kids? That is the key point to the teachers. You as teachers, this is what I'm talking about. So how to teach problem solving? First of all, I say that foster a problem solving framework. That is the important thing, okay? In other words, students cannot solve a problem haphazardly. You know what's haphazardly? Randomly. Anyhow solve. A do it this way, B do it another way, C do it another, totally different, don't know. They're highly unstructured the way they're doing it. Just by luck, they managed to solve it, that's it. After some time I have to do again, they say, I can't do anymore. The whole idea is to adopt a structured approach. The key was a structured approach. And Poya gives us a structured approach, a 4-step, very structured. Understand the problem, devise a plan, carry the plan, and then, last but not least, look back. Very structured. It's easy. Because you have your mind to think through, to analyze it step by step. And the 4th step, I say, is not one way straight, you can go backward also, by the way. So you can go back and forth, between step 2 and step 3, or step 2 and 1, well, you can go back and forth. So this whole idea, a structured approach. Okay? So therefore, I would say that you get them through the what? The Poya 4-step. And teach them how to apply strategy, like I'm telling you now. But again, with the kids, probably those terms are used here. You may want to use it on the kids. Look for patterns and say, okay, say, kids, do you see any pattern? They will answer, do you see any pattern? Say, yes, I don't see pattern. Or can you draw a picture? You can use words like this, very layman's word. But they don't know that these are called strategies. But what they know is that if I can't do it, I will draw a picture. Or I will make a table. That's all they will know. The whole idea is to, foster a problem-solving framework in a very structured manner. So that is the whole idea about doing it when you teach them about this problem solving, okay? The first thing is to foster a problem-solving framework. Now, for example, in this way, I'm not going to ask you to solve enough, okay? You're talking about two persons, let's say started in the opposite direction, in a circular running track, okay? 400 meters whatsoever there. And they're running at a constant speed, but the speed are different. Okay? So one is 1.6 meters per second, the other is about 2.5 meters per second. So they both run. After how much time did it take for both of them to meet for the first time? Because they run around, right? So, of course, they move in the opposite direction. Somewhere along the line, they will meet. Now, they start at the same time. So the question, but of course, if they keep doing it, they keep meeting a few more times, right? But we want to know the first time. They meet for the first time. When they run the track, I don't know where they meet. Park somewhere, they will meet somewhere. So, how much time did it take for them to meet for the first time? You follow me? At the meeting point. So this is the kind of question there. Now, again, you have a picture there. So see how they would have to analyze this kind of a question using Poya's 4-step. Follow me? I'll just give you one example. Now, when you teach them Poya's 4-step, these are a few things you're going to bear in mind. Avoid using academic jargons or technical terms or labels. Please don't use all those things there. I mentioned that the whole idea is about all those labels, but the understanding of the concept without knowing the label, but kids they can learn better. Cultivate a growth mindset or Poya's 4-step. I think it's important. Student must have a growth mindset. The saddest thing about students is what? They have a fixated mindset, fixed already. He keeps saying, I can't do. Huh? That's very sad. Huh? There's nothing that you can't do. We say, you can. We say, you can't do. This is mine, I mean, sometimes kids, you have to really help them to, it's their own personal, I don't know, they try to, their own personal psychologist, I cannot do. If the kid thinks, I will fail, I'm sure he will fail at the exam. Am I right? I can't do this one, I will fail. Come on, it's not true. I never think that a kid to say, I will fail all the time. Actually, they can do. The trouble is that because they don't spend much effort, they don't think very hard, say, I cannot do it, simply give up easily. If kids give up easily, I can tell you, if that's the way they go in life, they'll give up easily. They will never succeed. You see, so the whole idea must cultivate a growth mindset for the poor steps there, okay? Help them to conceptualize the problem before, solving it. Now, solving can be a very visual way of doing it, or in drawing, by the way. You can draw pictures and solve it. Don't say, we're writing now, must be right now. Draw pictures or see what's going on, have a picture there, whatever there, in order to solve it. Try to have a concept of how it looks like before they apply the strategy. So that is the way, you want to teach the poor 4 steps. These are the things that you have to watch out for. Okay. Now, I give you this PSLE question. This is from 2024. What was last year, by the way? It's the last question. This was the last. This year is not our year, by the way. This year will be end of it. Okay. This was the last question. Paper 1, question number 30. With 2 papers, 1 and paper 2. Now, you look at this question. It's a very cute question. I would say that a teacher pinned 22 hearts and 2 stars on the board. Each student in the class then placed either 5 hearts or 8 stars. At the end, there were an equal number of hearts and stars pinned on the board. What is the fewest number of students in the class? Oh my goodness. Now, I want you to have this scenario, a class of students. Okay, Imam teachers, I come forward, and here's the board here. I will pin 22 hearts first, and I pin 2 stars on the board. Now, after I've done that, I say, okay, students, now, come forward one by one. You can pin over here, you can pin either 5 stars or 8 hearts. Only what you have to choose. You can decide to pin 5 hearts, or you can choose to pin 8 stars. So that's what they're doing. So one by one, they come forward and they will pin. Now, we don't know. Some may pin 5 stars, or some may pin 8 hearts. But what happened is that after they all have finished, then you count the number of stars and the hearts, they are the same number. So, assuming that each student have a chance to do that, the question is that, what is the fewest number of students in the class, the smallest number in the class, to be able to meet these requirements? Now, how would you solve this problem, by the way? Use a table, okay. What table do you want to use? Okay, now, so just use a table. Okay, you can use the table. Okay, you just stop it there first. Okay, never mind. Okay, no. Okay, never mind, it's okay. Now, tell me, it seems that he tried to alternate. When student give 5, then there was 8, 5, 8, 5. It doesn't really matter. The order doesn't really matter. But why you do it this way? Can you please tell me? You must have a reason for doing it, am I right?
Trying to find
Now, let's add up. Let's add up to here. Let's add up, okay? Let's add up. Because at the end, there must be an equal number. Now, here, you add up, it'll be what? 30, 32. You add up here, you have what?
18.
18, am I right? Good. No, it's a good idea. Actually, he tried at random in a way. He start with a guess and check, roughly. It's okay, it doesn't matter. But strategy can change. Up to a point, I just stop. And if I alternate it, as well, I say, okay, the first one put 5. Doesn't matter whether I put 8 or 5, doesn't really matter, this one. I just do it in 2 rounds. So at the end, I add up to be 32 and 18. And you look at it, what happened? Because at the end, they have the same number of hearts and stars. So you see that if you start doing it this way, to catch up with this one, does it give you the idea that there may be a bit more people putting the hearts to match with this number here? So you may want to change strategy to add more hearts over here. So as you go, so in other words, if you were to do this, you have to accumulate the number of, if I were you, I would put 2 more columns there. This is a cumulative, okay? 2 more columns here. This is what? Number of hearts, number of stars. Now, up to here, of course, start with teachers. One is 22 and 2, fair enough. Up to here, you have what? You have 7. You have 27, and then nothing is still 2. Am I right? It's still 2. So you see that. Over here, you got 27, and then you have what? You have 8, right? 8, which is 10. Am I right? So that's how you would accumulate that. So you get another 5 there. So you got 32. You got 32, and this one you can still have 10. Now, so the last one is 32, and then you got another 18 now. You can see from here, that's easy to accumulate from this side as you go along. Then you see that which side should I add more, which side should I get less. So eventually, when you try to increase here, as you go along, then you will meet the same number at the end of the day. Actually, they are not. And if you know that you don't to catch up, I add a bit more, it will catch up with this number a lot faster, in a way. Am I right to say that? So I may put more hearts, no. But sometimes along the way, you may add another one, which is more stars, and along the way, you may add about more hearts. So that's how they will use this kind of table to organize it, to answer this question very fast. It's a good starting point. I would say that the kids will always, the kids may have different numbers, but they have to count. Each one will add something there. What's the total for both sides? And then they'll try to balance it. Yes, it's a guess and check in this questions here. It's all about counting. It's all about counting this one. It's not really such a complicated skill, but lots of thinking is going along. So that's pretty well the kind of question that people they will ask. How many times that I should get? Of course, along the way, they can skip a few more. They will know how many that they should add. All right. Okay, I go on. Now, this is from China, primary school. This is a grade 6 question. China. They have a right angle triangle. Watch out here, the right triangle. They got two semicircles, am I right? Two semicircles. And of course, they overlap each other. And you are given the dimensions of the right angle triangle. This one is a 4, BC is a 4 cm, AC is 8 cm. And they overlap. Now, these are the shaded area, am I right? There are 3 shaded area here. You're supposed to find the shaded area. What's the size of the shaded area? These 3 add together, in other words. Now, in grade 6, students have already learned how to find area of a triangle. They've already learned how to find area of a circle, so then you can find the area of a semicircle. Fair enough? Okay. So with all this information given them, how are they going to figure out what's this shaded area add together? There are 3 shaded areas. Add together, what's the total area? That's what it is. It's not a difficult question, to be honest with you. It looks complicated, but it's not. If you think about it very carefully, how to analyze this question now. I want you to think about how to analyze this question. When I first look at it, I said, wow, it's complicated. Actually, when I think through it, it's not really difficult. But the way you look at it makes a difference. Now look at it again. Try it, never mind. You can try and see what happened. How are you going to analyze this question? You know the formula for finding the area of a semicircle? Circle is what? Pi r squared, right? So semicircle is what? Half of it. Fair enough? So you know the semicircle area is what? Half pi r squared. And your radius is given you. Fair enough, okay? This semicircle, radius is what? 2. This one is 4. So you know already, yes. So that's it. And a triangle, also easy to find the area. So you can find the area of a triangle, you can find the area of the 2 semicircles. So for a start, what will you do? You find all those areas first, that's the easiest of all. Don't think very hard, am I right? Yes. You see, in your mindset, I don't know what to do, but at least I can find all the areas, semicircles and triangle. You find them first. That's good enough. Then after that, you start looking at which part is shaded, which is unshaded. That is where you have to separate the question. You don't think all together. How to solve it now? I break into parts first. I look at all the areas, and then I try to say which one is shaded. That is where you start thinking about it. Yes. Okay. Okay, let's start with this 3. That's the easiest of all, right? Now, who can tell me what's the area of the small half of the triangle? Just shout out. What's the area of the triangle? Anybody? Come on, that's an easy one.
60.
60?
60.
16. Okay, all agreed? 16, right? cm squared. Then the small one. Who will tell me? At the back, you want to tell me, the lady at the back, come on. What's the small semicircle? At the back here, you're going to take the semicircle? The small one. It's what? Half pi r squared. What's the r is 2, right? It's 1/2 pi what? 2 squared, isn't it? So you end up with what? Is it 2 pi? Is it 2 pi?
2 pi.
Is it 2 pi?
Yes.
2 pi? No. I mean, I give you this formula here, as I said.
2 pi.
2 pi? Am I right? 2 pi.
Yes.
Pi is what, by the way, if you know pi? 3.14. Easy, I mean, the 3.14, you use it, 3.14. Okay? That's what you have. How about a big circle? How about a big semicircle?
8 pi.
8 pi, all agreed? You have what? Half pi times
4 square.
4 squared. With 16, half 16 is 8, right? 8 pi. Okay, now these are very basic. You can all find, kids can find all these three. Now, after all these three, what you shall do? What shall you do? Maybe I cannot write on the white, I cannot write on the smart board here. Can I write here? I cannot write here. Can I write with the marker here? Cannot mark. At the back, can I put the marker pen here? Can I? Okay. Hopefully it will not. Now, this one is, I erased all those. Goodness, how can I erase all the numbers there? Sorry. I erased everything. This one is what? 16 cm squared. This one is what? 2 pi cm squared. This one is
8 pi.
8 pi.
Yes.
Okay, so I found all these three at first. That's the easiest of all, right? Now, after I've done that, I said, remember, then we're supposed to look at which area is shaded, which is unshaded. And we look at how many areas are there altogether. I hope I can erase it. Can I put it on there? You see? I can erase, that's good. Okay, so I call this to be area 1. How about that? Okay? This is area 2. This is area 3. This is area 4. This is area 5. Am I right? So I know how many are shaded, how many are unshaded. Now, what am I supposed to do? I'm supposed to find the area of what? This, and this. Am I right? I'm supposed to find areas of what? 1 plus what? 3 plus 5. Am I right? So this is shaded. Then the unshaded must be what? 2 and 4. Now look. So now I look at what I need to find. You see, first of all, I find all the areas. I don't care what's shaded. I just found everything. Then after, okay, I say, what's shaded, what's not shaded. So only these three are shaded. The others, 2 and 4, are not shaded. Now I see how this being related to each one of them. Now, let's look at the triangle first. Triangle is made by how many small sections here? It is equals to what? 1 plus 2 plus 3. Am I right? Am I right? 1 plus 2 plus 3. Then this one is equal to what? How many? 3 plus 4 plus 5. Am I right? And the big one, oh, sorry, the triangle is not 1, 2, 3. The triangle is what? 2, 3, 4. Sorry, 2, 3, 4. I make a mistake. It's a 2, 3, and 4. Sorry, it's my mistake here. Am I right? 2, 3, and 4. So that the big semicircle is made up of what? 1, 2, 3. Am I right? Now, what I want is what? I want 1, 3, and 5. I want this view. So if I want this view, I want 1, 3, and 5, by the way, that means I must add up this together in a way. You follow me? I must add all this together. Am I right? But the trouble is that when I add up, I always end up with something which I don't want. Fair enough? And this one gets repeated. So how to get rid of this one, and this one? Oh, I see that this 3 is made up of what? The triangle, am I right? So in other words, if I begin to see this pattern, that means I can take the sum of these 2 areas of the semicircles, I take away the area of triangle, I should get all this, am I right? So now this becomes the area of the small semicircle plus the area of the big semicircle minus the area of the triangle. I should get my answer easily. So that means once I have that, it will become what? 2 pi plus 8 pi minus 16, which is equals to 10 pi minus 16, and that's where you can calculate the 3.14. You get our answers already, by the way. Okay? You see that? So it's not a difficult question. It's a matter of how they will do, reason out step by step. Now, I repeat. First of all, I don't care anything about overlapping. I know how to find the area of these 3 objects, the triangle and the 2 semicircles. Straight away I do that. After I've done that, I begin to start looking at which area is shaded, which is unshaded. And I start labeling all the things here easily. And I see that each shape is made of how many shaded, because it's a mixture of shaded and all mixed together, right? So I can start doing it. And I think, then I discovered, oh, actually, that's how I can find it. You follow me? So that is the way the mind's supposed to work. Once you know it, actually it's not that difficult to do it in a way. There's no complicated calculation here. Any questions so far? This is from China, by the way. It's not from Singapore. Singapore don't have this question, but China have. It's a good question. I looked at it, and I like it, so I thought that myself, sorry, I better erase it, all the thing on the smart board here. Okay, bring it back clean. What do you think? Can help a student to learn how to think, you see? It's not about thinking It's about thinking skill. It's not really about simply doing all the calculation. Calculation is very straightforward. Okay, let's go on. Oh, I think I can let you go back earlier. Okay, another thing is that try to scaffold your problem gradually. Don't jump into the deep end of the pool to swim. At the shallow end and go to the deep end eventually. For example, if you were to, it basically is to have what? Start with simpler problem and gradually increase the complexity to build their confidence and skill. That's important. Students, you need to boost their confidence. So don't straight away get a hard one, a simple one first. Okay, for example, the word problem, something like this, about percentage, okay? A customer bought a hard disk at a discount of 15%. If the list price of the hard disk is $120, how much did the customer pay? A lot easier. You know how to find the percentage? Take away, the so-called discount, and they will know how much the customer would pay. And then, after they can manage to do this kind of problem repeatedly, a few of them, they can go to another one a bit harder. Now, this one go to GST, for example. The restaurant gave the customer a discount of 10% when he paid with his e-payment special. But then, of course, there was 8% GST added to it. If the meal cost $84, how much did the customer pay? Typical restaurant, you got a restaurant there, oh, you got a discount, okay, there you got a discount, but still they pay the GST no matter what. Malaysia is how many percent, Malaysia?
No, they abolished it.
Huh?
They started, then they scrapped it out.
Oh, no more already, yeah.
We have an SST called 6%.
Okay, okay. It says SST, isn't it? Okay. Huh?
Only the name is different.
The name is different, yeah, okay. They call by name they want. It's still a tax, no matter what. You call it by GST, you call it, okay. Singapore, by the way, is quite high. It's 9% though. Singapore is quite high. It's even increasing all the time anyway. So, okay, never mind. All right. Okay, you call it SST, you call it GST, it's still a tax. So, this person, maybe he do the e-payment, there's a promotion there, he gets some discounts. All right, so we told the discount, oh, okay, you get 10% discount. Maybe this is a promotion, you get 10% discount, whatever. But I still have to pay the GST or SST, let's say 8%. So the meal costs $84, how is he going to work it out? It's a multi question, they can work it out then. Now, this is more advanced. During the bird flu period, the price of eggs increased by 5%. Later, the price further increased by 10%. Very bad. Not enough eggs, okay? Go further. This has made the price of eggs increase by $4.60 per dozen. After all this increase after increase, what was the price per dozen before the bird flu? You follow me? What was the price before the bird flu? Now, so here what you see, the price increased 2 times. Am I right? After bird flu, okay? The bird flu, 1 time. The first time is 5%. Another time, 10%. So, what was the price before the bird flu? That means the original price. They had to work backward. Am I right to say that? They work backward. So, the final price is what? $4.60. They work backward. Of course, the original price must be lower than $4.60. So, what is the original price? So, that's a kind of a question. It's a bit harder now. You have to go from simple to moderate to advanced. Okay, so far? Now, you can develop students' thinking skills and reasoning skills. One good way to do is have games and puzzles. Please do. I would encourage games and puzzles, okay, to develop that. This will help students, in the problem solving, by the way, if you use it. Like this, a game. Now, let's play this game. For example, the squares are here, right? Fill the squares with numbers. I give you all these numbers here, so that each line added to be what? 60. Fair enough? So they will do it and see how it will be done. Simple games for the lower grade, pure addition, that's basically what this is. Or you can have something a bit more complicated. Now this time I'm giving them the so-called decimal numbers. Again, same thing, okay? such that what the numbers in hexagon, this hexagon here, is the sum of the two circles. Like this one here is the sum of these two circles. This one here is the sum of these two circles. You follow me? So numbers are given them from 0.1 to 0.8. Put in all the numbers such that the number in the hexagon is the sum in the two neighboring circles. That's it. So it's a game that they can do it. It's to help them to develop, you know, this so-called thinking skills and reasoning skills. Now, another thing is try to promote group work. Students love to work in groups, not as individuals. Sometimes you do that, okay? To allow them to share ideas, learn from each other, and learn also to communicate, talk to each other. That's important. You see, one thing good thing is about group work or group activities is that you have to develop a kind of a skill called social skills, how to deal with another person. Kids need to learn social skills. Because when they go out to society there, they know how to associate with another person. Fair enough. Social skills is very important. So, okay, you help them in the activities and through puzzles and games. It's the same thing, you know. You can, for example, create an activity, draw this kind of a triangles, you know, and ask them to paint. They can draw this and paint these triangles here, for example, all this thing here, and they can do it. They can do it as a group work. Two persons work together as a pair of them. They can start sharing the work, and then ask them to calculate how many shaded area. Of course, this one is very easy. Shaded is only 1, unshaded 0. There's nothing unshaded, so 0 is fill all the figures. So they start doing all those things there very simply, and see how they would do to do it then. So it's a kind of group work that they can do, all right, to find out all those things there. In fact, they can even find the percentage or the fraction, what fraction of the triangle is shaded. If you take this to be a 1, then you see, what fraction of the triangle is shaded? You follow me? Can they see that the shaded is basically is what? 3/4 of the triangle. Because unshaded is a 1/4 of a triangle. They can start thinking about it. But as they go along, it's getting a bit more complicated. So that's how they begin to all this answer all kinds of questions there, and they can form a group or a pair of them to decide how to go about doing it. They have to interact with one another. Come on, children can learn with each other. They can, you know, sometimes it's good to hear from teachers. They will learn from each other. So this whole idea about collaborative learning. So they try to promote collaborative problem solving as such. It's more fun for them to do it in this manner. Fair enough. You're free to create any kinds of activity. This is only an example. Or something like this for the lower grade. Okay? Use the weights on the scale to determine, you know, the weight of each egg. So, assuming you can stack all the eggs, you can't set the eggs order, but assuming you can stack order, so you can say 12, this 3 is at 12, this is 13, this is 14. So these are let's say the number of grams. 12 grams, 13 grams, and 14 grams. And so ask them to figure out what's the weight of these 3 types of eggs then. So this is another way of doing it. Of course, it may not be eggs. You can have balls if you want. It's the same thing. You can have balls instead of eggs. Create your own. Follow me? So these are the things. It's good for students to learn how to do reasoning, thinking skills. Everything comes in very handy through collaboration. And also incorporate real-world context now. One thing about mathematics, students don't see it real in the real world. That's where they have to start, you know, looking at mathematics from the real world context. I think one of the good things is about measuring ingredients for a recipe. You know, when I was telling you about this one yesterday, I went down to the downstairs there. They have this home economics. I think they will make what kind of kueh is that? Ondeh, isn't it? They make ondeh. I see there, the kids are very interested in making ondeh. I say, interesting, and do all kinds of measurement. How many scoops, measuring cup, they measure everything, you know. Now, it's a good way to learn. It's a good way. Recipe is a very good way to learn. But recipe only tells you to make, let's say, maybe one cake or two cakes at the very most, right? You want to make 10. Now, what's the amount that you need to do? What they need? They have to apply what? Proportional reasoning. Remember I talked about that? Oh, I need how many times? I multiply how many times? So they will learn all those things there and apply in the real world. The kids, oh, now, why not proportional reasoning? I can use it on my recipe. They can do that. So, in fact, all this home economic activity, making kueh, making all kinds of things. I make all kinds of things. The drinks also make drinks, and I see that once they make drinks and all things there. And it's a good way to help them in problem solving in the real world context, how they apply the strategies in handling all these problems. Or sometimes you can give a map scale to calculate the distance. That's good. They can calculate the distance from using a map scale. And they will do it, or they can even draw it or whatever that is. So these are kind of things, for them to see that math they learn in the textbook is real in the world. They can use it as such. So these are only two simple examples. Of course, there are many other real-world contexts that you can use to help them. Okay, I always say this. Focus on the process, not just the answer. I think that the important thing is what? Is to show their work and the reasoning. Even the final answer may be incorrect. That is important because in actual marking, examiner or teachers only look at the what? The process. Your answer may be wrong due to carelessness, but you won't lose all the credits. You still got marked, you may lose about half a mark or at most 1 mark. Because your answer is incorrect, but you still keep most of the marks for that questions there. So the process is more important because the process will show the mindset, how they think, how they reason. That's important. All right, So this whole idea here. Now, when students make mistakes in the student process, they know finally the answer is wrong, but don't tell him where they make the mistake. Let them identify where they have gone wrong. That's important. They discover themselves what has gone wrong. Don't tell me, oh, this is wrong. Oh, this is wrong. I just correct it. They never think that's no good. You have to make them, can you tell me where you make a mistake? They're going to find out themselves. You see, one thing about kids, if they can find out something through effort, I think they will learn better than what you tell them. Am I right? You tell them, oh, this is wrong, they will correct it. Tomorrow they forget again. They'll do the same old mistake. But if they see it there, oh, this is why I made a mistake, I change it, good. So I think that's the whole idea about learning. Don't be afraid, don't be afraid of making mistakes. It's not fatal, it won't kill you. Of course, some mistake can be very fatal. If you put your hand inside the socket there, thank you very much. Don't do that. That is no second chance. That's the first and the last chance. That's all you will have. So please don't do that. But if you miss a comma or you miss a right answer there, it's not fatal. You still can learn something about it. So I always call that kind of mistake is what? Mistakes provide opportunities for learning. And I like this kind of thing that we take it very positive. Don't think mistake is bad. No. Mistakes provide opportunities for learning. That's the point I want to emphasize. Actually, sometimes we learn better through mistakes. Actually, let me ask, who on earth never make mistakes in this whole world? We also make mistakes. And there's one saying, the only people that never mistakes are people who does nothing. He will never make mistakes because he does nothing in this life. I don't think we want to be like this kind of people, right? We don't mind do something, make some mistake, we know, oh, where we've gone wrong, we can turn around and make it better. This is all our life. Something is real in the real life. Put it this way. We ourselves make mistakes, fair enough. Then we correct it. We do something right again next time, whatever that is. So I think this is a good way to tell them to focus on the process, not just the answer. And don't worry about making mistakes. You will learn better at the end of the day. Last but not least, encourage perseverance. This is what I talk about. Very much lacking among the students there, all right? So you can give them a classic problem, something like this. Let them go and think through how to do it. I think it's in there, in your handout there, okay? They can think through it. Don't give up so easily. And they must learn to what? Justify the answer. Please don't give an answer. Why you think is correct, you tell me. That is important. It's about fencing, an area. Okay? The farmer will do some fencing there with some material and see, determine which dimension can maximize the area. Please tell me why you think what you've done now is with the maximum area that you will get. Justify it, please. So these are kind of question, it is good. And I like this quotation from Albert Einstein. If I have 1 hour to solve a problem, I will spend 55 minutes thinking about the problems and 5 minutes thinking about solutions. My goodness. Of course, his problem is a lot more complex than our problem. So I spent 55 minutes looking at the problem before I talk about. Last 5 minutes, I do my solution for it. That means the first step in understand the problem is important. Though the kids may not spend 55 minutes there, at least spend good enough of time to look at the question and break it down, analyze it, know what the key information before they solve the problem. Kids are very impatient. They see a problem, I want to solve it immediately, am I right? They never think through how to do it. What do you think in a battlefield? If the army, they see an enemy, charge over and go and fight, do you think they will win it? I don't think so. You never think how to fight the battle. Before you go over there, you already get gunned down already by your opponent, right? So please, don't do that. Spend time, understand the problem. So that's basically what it is. Encourage metacognition. Again, I think I talk about a lot more about try to reflect on what they have done. All right. Now, as a teacher, you may use the following prompt to guide them in the metacognition. I give you some of the prompts there. Tell them what strategies work, what it works. Tell me that. Okay. Where they get stuck, tell me where they get stuck. They can tell you where they get stuck. All right. Okay. How would you approach a similar problem differently? So these are questions you can prompt them. Can you find another way to solve the problem? I get stuck. Can you find another way of doing it? Look for it from a different angle. Please do that. Or you may give them a hint. You let them think about it and they will just get it done by all themselves. See, the whole thing is that kids must learn to solve problems all by themselves. You guide them, yes. You only guide. But you never give a solution. When you get a solution, you say, I know solution. Just copy it down and let's get it. It's all done. But they will never learn if you do it this way. Okay? So these are kind of a thing as a teacher you can help them in this one here. So I think that's very briefly, I just summarized all this thing here about problem solving strategies. How do you find? Is it too much? Too little? Or enough? Just enough? Enough? Okay, enough is enough. But I think it's okay, don't worry. If you see this for the very first time, I understand. That's not the issue there. I think what you do is that you go back, you slowly look at it again, slowly. You have all the notes here, look at it, and try to bring it to your classroom progressively, not all in one go. Slowly, you use it until you're comfortable with what you are doing. All right? Then you can, eventually you can handle most of the problem-solving strategies here. Okay, before I go, I think there will be a certificate of attendance to be given you. I think they put it here. Okay, may I know who are the people? You tell me. Ivory, Mark, you are the one. Okay, you are the one. I think this one must be yours, I believe, right? Yes. Okay, this must be yours. Connie Lim, yes, it's yours. And Emily, it's yours. And Amanda is yours, right? So you are the one. Okay, so this is the attendance. Okay. All right, fine. I think, okay, I end it just before 3. So hopefully you find something useful, informative, and you can use it to benefit your students. Okay, thank you very much for your time. I know today is Saturday, so I'll take you a bit earlier. It's okay with me.